progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend Tumo centers each week after school. Tumo offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders. Project labs with international professionals. At Tumo, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several Tumo centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend Tumo centers each week after school. Tumo offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders. Project labs with international professionals. At Tumo, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several Tumo centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend Tumo centers each week after school. Tumo offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders. Project labs with international professionals. At Tumo, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several Tumo centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend Tumo centers each week after school. Tumo offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders.
Rapid pace. Here's last couple of months. Marked contrast with growth and development of education over the centuries. Education train is whizzing past the velocity, and it's want to hit your wagon with the hope of accelerating get to a that we would get us to. Changing train, a ride at risky. To get together abilities and challenges, the project of education system with rooms and classrooms, and a way that's safe. We have a high-powered morning earlier, almost a dozen workshops on design of AI to the graphic storytelling, a series of sessions. Now, headquarters in Yerevan. Other Tumo centers that many of them are in very global. Is there a new kind of developing as to AI technology about that? Is there anything we can preempt it? Very interesting speakers, educators to learners. Classroom and as well as primary. We know that AI do their homework, it corrects their mistakes, development. Is that all there is in education? What the are the potential, and then we'll talk about B.
project labs with international professionals. At TUMO, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several TUMO centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come.
To go to a higher level.
As teams
Large
progress
major
completing activities and workshops, their best results
a
are
field
uploaded to a digital portfolio, which acts as
observing
their
how they
living
behave.
diploma.
Living with AI. Implication. AI literacy considered
For more information, visit
in general.
tumo.org.
And that will be interviews, fireside. Right in. Honor of moderating. Globalizing. How can education and new our panelists. All right. So, I'm joined today by who is she's a vice president, one of
TUMO is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend TUMO centers each week after school. TUMO offers 14 learning targets at the intersection of technology and design. TUMO's educational software, the TUMO Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. TUMO makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs.
and finally,
Self-learning with help from coaches.
who's the FAST.
Hands-on workshops led by TUMO's workshop leaders. Project labs with international professionals. At TUMO, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several TUMO centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. TUMO is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend TUMO centers each week after school. TUMO offers 14 learning targets at the intersection of technology and design. TUMO's educational software, the TUMO Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. TUMO makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by TUMO's workshop leaders. Project labs with international professionals. At TUMO, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several TUMO centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. TUMO is a free-of-charge educational program that puts teens in charge of their own learning.
Technologies to your users on your platform. What are your thoughts? I'm sure you've been thinking about this recently. Can you share some of those thoughts with us?
You're on mute here, Hajjan.
Okay,
Okay.
not on mute anymore. Okay, yeah. So let me, talk from the perspective of education, So we have been investing in, mobile kind of code learning anytime, anywhere, And in many ways, technology helped to bridge the digital divide because with PCs and mobile phones, whatever was very concentrated in certain classrooms for certain locales is becoming, much more widespread. We have users around the world, people in India can learn on a mobile device, so all of that. What is happening with AI entering kind of education is, I think, the good part of it is that our average quality of education is going to go up worldwide. Because now with AI empowered kind of assistants, with AI, for example, you can teach code in a much easier way because AI can explain, your errors in a very human kind of, way. So you don't get intimidated by the kind of complex, tech jargon. And there are many, many things that you can implement. So in that sense, I think the average quality of education worldwide is going to go up. And it's a new platform and it's going to set the new standard. In terms of longer term competitiveness, though, average and decent standard is not enough. So what do you do to kind of, as a country or as a society or kind of, as a world in general to go to the next level? I still think there is this kind of teaching component that we are kind of often ignoring, you know, in the tech world especially, that is going to make all the difference. And when I talk about teaching, I'm mostly referring to, you know, schools and kind of teaching teenagers, you know, where do you start? Because a lot of learning will be like self-paced, you know, it's about how much you can learn on your own for you to stay competitive as an individual, you know, as a company or as a kind of country or whatever. But it's the difference of kind of, you know, like teaching experience, you know, how do you like awaken, you know, certain interests and certain passions in an individual early on, so they are kind of very well kind of, you know, just prepared to learn on their own, because technology is going to be available. It's more about, you know, where you put the effort and where you start kind of, and yeah, using the technology is super important. And then I agree with Claire, you know, like the next layer, application layer, is where every country in the world can be competitive. You can build a solution on top of infrastructure from anywhere in the world. So I feel like teaching and kind of, you know, just that early education that sets you kind of for competitiveness and global vision and doing things on your own is going to be even more important. And AI is going to give, you know, the best teachers that exist everywhere in the world more time and more kind of, you know, like basically resource to think about better teaching in general. So
yeah. So Armin, over to you. You jumped right into this challenge and are actually in the business now of providing, or at least piloting, and you'll let us know how it's going, AI education in high schools. That's something that's probably unprecedented. I know that a lot of organizations in the US are doing AI literacy and AI project, but this is actually core curriculum, right? Integration of AI into classrooms. Please start telling us more about that, and then please share your thoughts around the discussion we've been having in general.
Pegor, first, congratulations on organizing something of this nature. This is a critical discussion, and I'm glad that TUMO is at the forefront of this. And we have such wonderful panelists here, so it's a privilege to be here. You mentioned the divide, and you mentioned Global South. I think Global South is very, very vast, as you can imagine. I started working on this digital divide in late 90s, when we were still coming up with Millennium Development Goals, which largely failed, as you know. And then now we're here with Sustainable Development Goals, still dealing with Global South and integrating just base technology in most parts of the world. We're not even speaking about sophisticated technology like artificial intelligence, just base technology, and you have monumental efforts and obstacles to overcome. Just last week, I was in Africa, on the African continent. We were speaking about, actually these similar topics, and there's a broad interest on the continent to bring AI into general education in Africa as well. But our colleagues here mentioned some of the critical challenges that you have when it comes to integration of AI in education. One big element, I think, to be considered when we say Global South, what do we mean? There is Armenian Global South, for instance, where you're kind of in the middle of a pack. If it was a bell curve shape, we'll be sitting right there on top of the bell curve. And there is Global South, there is on the descending side of the bell curve, where infrastructure is not ready for any kind of an integration of artificial intelligence, not only in the educational platform, but also in the context of business integration to start with. So I think that separation or dissection of Global South is also important, because most people belong there. But coming back to the reality that Pegor, you were mentioning about starting AI education in Armenia, which is a pioneering thing, and I'm grateful. I think Hrant is part of this movement as well. He's a great contributor to the efforts. This could not have been done by a single organization. Since this being a pioneering initiative, we're launching in 16 high schools as a pilot project, 12 public high schools and 4 private high schools. That started September 1st. So already 23 or 22 days into this, setting up the infrastructure in these high schools, teacher training, which is a massive, massive task itself. And then the curriculum we worked on for several years we're at a point where curriculum is ready to be deployed. But training, because when we talk about any type of a knowledge, you have essentially 2 axes. You have one axis where the knowledge is, the other one is the human. So the question is, how do you take that knowledge and input it into the human? And it seems like a straight line, but it's quite dynamic. And here's where you can have the best possible curriculum, and if you don't have the properly trained educators, you're going to have a massive amount of challenge to take that curriculum and put it into that individual. Or you can have top-notch instructors, and if you don't have the proper curriculum in place, you're not going to get the most up-to-date knowledge into your students as well. And then there is this small thing called infrastructure. Haran spoke about computing power a lot. So having the proper computing power for you to be able to bring your student up to date, for them to be able to get into competitive education is also a critical element, because it's one thing to use AI, one thing to use AI competitively. You can run a program within minutes or hours, or you can run a program within days or weeks. It really depends how close you are to that top peak of computing power. And that's going to be a challenge that's going to divide Global South itself, because integrating proper computing and having access to proper computing is still a challenge. It's a challenge in Armenia, as you very well know, and it's a massive challenge in many parts of the world that are not at par when it comes to development, technological development that Armenia sends. There's a lot to speak about this, but I'll stop here, Pegor, and if you have further questions, happy to respond to those.
Yeah, I think your comments kind of gave me 2 different questions that I want to address to Claire and Hrant respectively. The second one for Hrant I'll come back to, which was about open source, so access to compute, but also access to pre-trained models, which is something we realized several months ago was suddenly much more feasible than we had thought. But Claire, I remember something you said, and that Armin is repeating during our conversations as we were preparing for this panel, which is some kids will have access to real teachers, human teachers, and some will have access to AI teachers, and there may be a quality difference there. Could you kind of elaborate on that? Because I think that's at the crux of some of what we're talking about.
Yeah, definitely. And I think, everything that was mentioned before is, our current state of play, but I do think there is an interesting dynamic that we've been also thinking about, second order effects, where if we think about the classic digital divide that we've been talking about today, it really centers around connectivity. I think that problem exists globally, as we've heard as we know and live that experience, but also, it exists in many developed countries, as well as, when we saw that in the pandemic and the differences in access to digital learning. But I do think if we posit the idea that eventually compute will go down, the rise of digital personal computers and the connectivity challenge goes away, then there is a very potential, almost different effect where you have this kind of third type of digital divide, where potentially there is a world where only people, the difference between the have and the have-nots is only people who do have access and the ability to afford. Real people will have real teachers, real humans. You can think of this even in customer service. We know that when right now, a lot of times you have to wait hours on a bot in order to get access to a human. And so maybe the people who can pay can get access to a real teacher and a real person that can walk through problems with them in person. And then we potentially have a future where the people who don't have the ability to afford this are relegated to only being able to learn from AI tutors. So I do think it's really important to really think about that kind of future and make sure that we're building AIs as amplifiers, really thinking of AI as augmented intelligence in the education system, as opposed to completely replacing educators or replacing deliveries of learning. And so I think it's very important, as the work that everyone in this room is doing, to make sure that everyone is cognizant of the way we develop AI in a way that it amplifies as opposed to displaces and replacing people.
Right. Another thing we've been thinking about is whether AI will be controlled by some companies, maybe governments, who are able to supply it, and then it seems fairly easy for them to drive their agenda. Everything from inserting advertising into the teaching to skewing the learning process a certain way, which has been done around the world with human teachers for a long time. But still, it seems like the more marginalized, the non-privileged learner is more at the mercy of these things than, let's say. So there's another sense maybe in which the digital divide. Maybe if someone want to comment on that or elaborate. Think about it as I jump to Hrant and with the open source question. Of course, compute is expensive. NVIDIA GPUs are not open source by any means, but at least some models are now, as opposed to during the months after, let's say, GPT 3.5 came out. Do you think that's a significant factor in this digital divide conversation?
Yeah, I think it's changing the game a little bit. So especially those recent large models released by Meta are making things easier for other players to develop their own systems. I also want to say that it's probably kind of luck that this happened this way. So it kind of some strange business dynamics between Google, OpenAI, and Meta that made this possible. Like if Meta was probably more competitive in the business side, they wouldn't open source it. So it's kind of a luck. So and it's very hard to count on that in the longer term, by the way. So we should keep this in mind that maybe 2 more generations of these systems, then there will be no open source ones. But now at this point, we are lucky and we have the opportunity to build on top of those. Again, it requires more compute than most of us are used to. And it's not only across countries, this divide problem, but also between academia and industry. Like if you go to research like scientific conferences on machine learning, you will see a lot of academic professors are in this challenge. They don't know how to compete. They don't know how to change their research strategies to stay relevant. So this disruption is prominent and is visible in many other dimensions as well. I think, the open source thing will help. I already know teams in Armenia that are trying to develop things on top of these open source models, including us on the research side. And the curriculum of AI in like universities and in higher levels should quickly adapt to teach students to leverage these new open source models to stay relevant.
Yeah. And Yev, I want to come back to you. First of all, if you want to elaborate on any of this conversation, but also the question of, as a company that probably is feeling the pressure to incorporate AI technologies, do you feel that you're playing in an uneven playing field, that the resource requirements are much higher, that you can't hire the people because they're overpriced, out of your range? Or do you think there's a way to play in that arena?
I think there is a lot of room to play in, honestly, and we have been using open source kind of, OpenAI technology for most of the AI experiences that we're incorporating in solo learning, over and over again. And with Meta's new release and, with kind of, I think that might not be such a big problem in the long run, because even if they are not open source, I think these models are going to become cheaper and cheaper, because that's what happens to technology. So I'm more optimistic on that front. it's more about the capacity, as you mentioned, like, can you build the expertise that can develop on top of those models? Like, can you get access to the talent that you need? I think that's like, so we have been able to kind of, hire people that we need, but over time, more and more people will go into this area. And I think it's just like with developers, in the beginning, it was very hard to find good developers. So, and it's not about prompt engineering. Obviously, I think prompt engineering is very much like Google search, that's how I see it. And then over time, it will become kind of, better and smarter, and it will do a lot of kind of work for you. You don't have to learn formal prompt engineering, but it's about, like pure machine learning and AI kind of expertise that you put on, like as a basis kind of your development work. But I think with like the more widespread AI becomes, the cheaper it becomes, the more people will go into the area, like into that area. So you may be able to hire great experts from Armenia, maybe. There will still be a bigger concentration in the developed world, obviously, wherever, the big companies are, and that's where most of the talent will be produced.
Right.
But, and another thing that is happening today with like business in general is we're all remote companies. So we're not limited to hiring experts in a particular location, which means we can hire people in the US, we can hire people, pretty much anywhere in the world. And it's about, what you do. And a lot of people like choose who to work with based on the mission, what you do for the world. And I think that gives you a competitive advantage to hire kind of the best talent worldwide. Again, I mean, it's not easy. It's never easy to attract the best talent, but I think like the world is becoming more and more global, and that's a separate discussion, whether that's good or bad, because it has all the cultural implications, and you kind of become part of a bigger, like global culture. But then it also opens up, huge opportunities for a company like out of Armenia, for example, to hire the best talent to build global products and kind of, and the technology is available to everyone. And I think it will become cheaper and will be more and more affordable over time.
And if I might add a quick data point on that, and I love what you mentioned around just the workforce and being able to scale the product delivery and just finding that talent. I actually do think AI is actually also allowing for a lot of the ability to allow non-technical people to build technical applications now. So because AI acts as this kind of queryable interface as a co-pilot, you're now seeing the ability for even non-engineers to be able to run things like data analyst sequences and such, or build applications because they can now leverage an AI co-pilot to help them do more technical activities and write code and develop applications. So you're seeing even tools like built for educators and admin, where you can talk to your data with AI, and the AI will help you pull reports, help you run that data. So just an interesting data point we're seeing with just how, the ability to blur the lines between technical and non-technical talent.
Yeah, agree 100%. And there will be more of it as AI kind of becomes more democratic in a way, and more simple to understand. So I think that divide is kind of, will be very easy to close over time as well.
This is good news. I'm glad to hear this. So Claire, following up on that, you see lots of pitches, I bet, and these days more and more about AI. And I know you write a newsletter, a weekly newsletter on AI, which I follow and I would recommend to everybody. What are some things you've been seeing that maybe are creepy in terms of maybe hinting at a non-rosy future of AI, of the kinds of things people want to build, or more in general, what are some trends that you kind of can glean out of the pitch text that you've been subjected to?
Yeah, I think we've seen a lot of this vision that now almost every profession, you'll start seeing these kind of verticalized co-pilots. So every type of work, whether you're a teacher, you're going to have an AI assistant. And I think the idea of these is to not replace specific jobs, but you've got companies like Harvey building a legal co-pilot, a bunch in the medical space. Basically, for any type of work today, a lot of people are doing unnecessary, what you might bucket as admin work. And so you now have the ability to leverage an AI, which acts honestly as kind of like a very smart intern, where you have to give very precise instructions, but when you do give it instructions, it can do a lot of that very admin work and reduce that, your cognitive workload. So that, for example, in the case of teachers, instead of writing up reports or emails to parents, you can spend your time actually teaching and what you love and are trained to do, which is teach kids and spend that time doing that. So we're going to see that. I think we're seeing a lot of companies building that application and that AI co-pilot vision. I do think there's a lot of exciting activity around multimodality AI. So, I think even in the broader marketing and social space, the ability to now actually, almost kind of clone yourself. So you have these influencers in China that are actually on 24/7 selling things because they basically clone their voice with just about 5 minutes of voice data. They can replicate your voice and they can replicate the way you sell things. And so you have, you can see how that applies at scale for news anchors or even your best teachers. I can have my own one-to-one version of Gordon Ramsay teaching me and walking me through how to cook. So I think really cool applications there. It is a little, I think, sometimes currently falls into the uncanny valley where you don't know if you're talking to a human or an AI, but I think a lot of really cool activity there. And then I also think, just the broader dream of this idea that AI can move education from one size fits all right now to one size fits one. So I think if you kind of think about the ability to scale teachers one-to-one, you can also have one-to-one lifelong learners or lifelong teachers alongside you. So this vision that an AI that knows that, okay, at home you're playing this game on Roblox, that ties to what you're learning in history class. The ability for AI to build those connections that maybe right now a human isn't able to see all the different things that you're doing in your life. I think when we think about the education system, a lot of cool applications are being built so that you can kind of connect all those synapses so that, the stuff that you're learning in your primary and secondary school, the teacher in higher ed or your university has that context. And then the same thing in workforce, the ability for, AI to connect those synapses so that I know that in university, you specifically took this class and read this books, and that's how it relates to your current work and such. So I think a lot of really cool stuff. I mentioned a ton of trends, but very, very exciting times. And I do think it is the time to build. This is, one of the largest value creation opportunities of our time if you're a builder or a founder.
Cool. So Armin, one of the things you said stuck in my mind that you've been in this business, if you will, for a long time. By that I mean the business of the developing world, trying to make sure it's not always playing catch up, trying to leapfrog, whether it's biotech or internet or now AI. And I wonder if you see kind of the same pattern, the same best practices, or is there anything different about AI? Because we hear that a lot. This is different. This is like the invention of fire or something. From the perspective of a development professional, let's say, putting that hat on, what are your thoughts about this moment in time in development?
Well, I think what happened was with ChatGPT, it kind of made AI popular. You needed a moment of that nature, and ChatGPT was just that. Because I remember, and Pegor, I think you can relate, when, and Nirant, you were part of it, when we organized our first workshop, which was machine learning with NSF. Remember that round? Armenian media published it as Mekena Shinutsu, meaning, they literally translated the word machine to like automobile development. And the reason I mention that, so we've gone a long way from 2017 automobile development to today understanding what critical aspect of AI machine learning would be, or these LLMs and all of these things. So people use these fancy acronyms now because they're aware of it, but that's not true everywhere. You still struggle with understanding what AI is, whether it's scary, whether it's going to benefit you, whether it's going to hurt you, how you're going to be processing it. And I think what Claire has highlighted here, and she spoke a lot about this co-piloting. This is important because co-pilot kind of brings an this element of ease, this element of reliability, partnership, so to speak. And I think when you look around the world, people begin realizing that there is a partnership between human intelligence and artificial intelligence, and this panic and paranoia that AI is going to kill you one of these days. It still may be true, so I cannot say that it definitely is not going to. But if it does, then we deserve it because we're stupid enough to create something that's going to eliminate us. We deserve that, if that's the case. But let's say we're not that unintelligent, and we're intelligent enough to create something that's going to go from co-piloting with prompt engineering to becoming a co-pilot in co-parenting in all sorts of, we've already spoke about from medicine to agriculture to military, to all aspects of integration that this can go in. But I think the next level, you said something bigger that, I think it makes sense today, but it may turn on its head. You said AI will be controlled by certain companies, and you're absolutely right. And I think what Taran said, which is also critical. Today, you have this almost like a panacea. You have Google, you have OpenAI, you have Meta, and you have others that are giving you a gift, this gift of AI. It's like, go and use it, and until you get hooked, and then they're going to say, well, you know what, to get rid of all these bots, we got to go behind the paywall. So please start paying for it, and it will become very unaffordable at some point. But I think there will be a time when AI will control these companies. They won't even know that they're being controlled, the same way we already are experiencing this. So imagine when you were doing all these researches, or you were doing research and you're obtaining knowledge. Right now, you were relying on yourself, right? You go and for hours, for days, for months, sometimes for years, you're trying to understand something, and then when you found something, you're ecstatic. You're like, you know what? I'm the champ. Here, you go and you say, hey, find me this information or get me this information. And the information comes in and you immediately start believing. You're like, okay, so this is what it is. Meaning it is already controlling you, but we have no idea that it's controlling us, right? Because we're getting this information and then we're passing it through as if that information is ours. We begin believing something that is not necessarily ours. So let's assume for a second that AI is still, whatever we tell it for it to be. But the minute it recognizes that it knows slightly more than us, it's like, I want to say AI consciousness. I don't want to say human consciousness because we have no idea what the hell the human consciousness is. Everyone has their own theories as to what consciousness is. But let's say it has AI consciousness. It's going to start controlling us, or in ways, in subtle ways. The types of information that it will possess, we can say it's how we build it, but it's also how it begins processing information, thinking that this is how best. It's like all these black boxes that come about in building new types of technologies. Those black boxes we're calling them black boxes because we have no idea what's going on there. So imagine if you have black boxes within black boxes that are starting generating information that is useful, at least on the side of AI, it's useful for human intelligence, so that information comes into our system. I think that's also an area that needs to be carefully examined, not to say, you need to be afraid of it, but carefully examined as to how we get impacted by this. And I think, Begor, you and I are probably old enough to remember some of the experiments like major companies like Coke and others had done in the past by inserting messages in their marketing campaign. And they're milliseconds, these messages that come into marketing campaigns, they're milliseconds, but immediately these messages stay with you and you think now you own this message. This is yours, you always knew it, but you have no idea where it comes to you. So I think some of these things are also something that needs to be carefully looked upon. I went slightly different route in explaining this digital divide and what have you, but I'm hoping that I've answered that and I opened another interesting topic to explore.
Yeah. So along that kind of more paranoid, if I could call it, line of thought, let's talk about regulations and regulatory capture, but maybe more relevant to our topic, this idea that countries can compete on having more lax regulation, for example. Like we've seen the UK try this to some extent, definitely Japan with its policy on intellectual property and how you can train your AI. Anyone want to jump in on that topic of kind of the global differences in terms of AI policy and how strict or not strict they could be?
I'm happy to comment on that. I actually, this past week I was at a Summit of the Minds where this topic was widely discussed, regulation of artificial intelligence. This is it's a sensitive topic, because I mean, look, it's like, let's say on this panel we have Hrant, we have Yeva, we have Claire, we have you, kind of practitioners of artificial intelligence. And then when you get to regulators, these people, most of them have never even used artificial intelligence. They haven't slightest idea as to what it is. And now we're giving them the power to regulate something that they don't understand. And when you don't understand, you always work from the point of fear. So you want to control it. And we're control freaks as humans, right? We want to control everything. So now bringing that type of a control on, unabated control versus unabated innovation, it may stop some things on tracks, although I don't think the humanity at this point, no country can control this properly, because if you begin controlling in the United States, it's going to go to South Korea. You start controlling there, it's going to go to China. You start controlling there, it's going to go to Singapore. You start controlling there, it's going to come to Armenia. So the point is, it's going to be very difficult to control it, but also having this arrogance that we know best how to control something that we don't understand, it may backfire. So I think, all of these conversations that we need to bring regulatory framework, we absolutely need to have a regulatory framework that actually allows you to innovate and innovate smarter. But the point should be not control. The point should be, how do we empower you better? But that's a very different approach. So if you're thinking how I'm going to empower you, you have a different type of a mindset when it comes to a regulatory framework. Whereas when you say, I'm going to control you, it's like, rearing kids. It's one thing to say, I'm going to control this kid. Another thing, you're going to say, I'm going to make this a fantastic human being. The one that you're going to control, you're going to probably screw that kid up for the rest of their life. So I think, that is critical for us to understand who the regulators are, who the people are that are planning to do this, and then what type of a mindset they have when they're approaching actual control of artificial intelligence.
Okay, so, Claire is the only non-Armenian, as far as we know, in this panel. If you're advising the government of Armenia, would you go towards make your regulations very lax so you can, be what Switzerland is to banking, Armenia would be to data or something? Or would you say, no, you're very vulnerable, protect your population, make sure you have all the right regulations? I know that's an unfair spot to put you in, but if you would improvise.
I guess I'm deciding the entire fate of Armenia's AI policy, but I do think, as Armin mentioned, it is so tricky, and I do think, right now we've never dealt with something like this before, and I think policymakers and ministries are trying to make the best of the situation and trying to operate a little bit out of fear, because sometimes it's better to think that you're controlling something and not let it out the box. But in reality, Pandora's box is open. And this technology is like Promethean fire, right? It could be the best thing to ever happen, but it could also, be the reflection of humanity's worst qualities. And as I mentioned, there is a potential for, some massive existential threat. But I do agree. I think what I would advise is ultimately, I do think regulation, as we've seen this story before, it does prevent competition. And if anything, I do think it creates a market where incumbents thrive and kill startups. And actually, you kind of maybe are seeing why this is why, in the US at least, OpenAI, Meta, Anthropic, they're all convening. And a lot of times it's actually a kind of a form of regulatory capture where because they are the incumbents in the space, they can regulate it. They can say, oh, in order to build a model, you have to hire XYZ amount of lawyers and XYZ regulators and red teams. And that means that startups won't be able to build in this space because only OpenAI can afford something like that, right? So I do think there's that trend that to be aware of in thinking about regulation. I also think just broadly, if you look at every industry that is highly regulated, healthcare, education, energy, the cost of those things are driven up high, and it's because there is regulation in this space. And so I think I don't want to jump into conclusions what this looks like, but I just do think it is important to think about how regulation shapes not only the ability to create startups and builders in the space, but also industry progress, and just thinking about like the ability to build applications in this space. But I also think, we can also learn from other examples. So the UAE released their Falcon 40B model, which is open source, which is very exciting. And Japan, I know, is working on their own version of a couple models. So I do think countries are being very, thoughtful about this process where they are experimenting and also driving towards a purpose of building models that are also more culturally sensitive and contextualized to their countries. And I do think that's a really good, or at least I would think that is a exciting development, because I do think, hopefully those models will lead to better products for their own countries as well.
Mm-hmm. By the way, we've been getting questions from the audience. Some of them are being upvoted. One of them is really interesting, and it brings us right back to the education question and human versus AI teacher. And the question is it possible for AI education to link the learner to the real world? In other words, you would think that if you're working with AI, you're isolated from the real world, but can we imagine an approach where that would actually be a very healthy relation with the world, social, mitigated by AI? Anyone want to jump in on that one?
I can try to answer this. So, in my opinion, the technology that we already have is capable of solving so many interesting problems and becoming a source for so many interesting solutions that can solve very different problems, including the one that is mentioned in the question. I think it's more about how to package this, how to design the user experience on top of this technology so that it can solve the problem that you're targeting. So I maybe cannot comment on the exact specific problem, but I think in general in education, whenever I think about it, the bottleneck now at this point is not the technology, but the user experience, the user interface, the way students interact with the AI. And this is good news in some sense, because it means that a lot of people who know education, who know psychology, who know how to deal with people, what people like to do, and those people who can develop those interfaces, they have the technical means to bring their ideas into life. They don't need to hire AI experts somewhere, right? Like the best AI technology is available to everyone, although it's not free, right? On the other hand, the other side of the medal, especially for countries like us, is that there is a small risk there that any country or any technology ecosystem that is trying to position itself as a source of technical talent, it's kind of losing its competitiveness, because you don't need that much technical talent if everyone is using OpenAI's technology. So the focus is on the UX side. But yeah, in the scope of this question, it's only good news, and maybe this is a call for education experts, human-computer interface experts, to jump in and find solutions to these educational problems.
So yeah, one of our other panelists for another panel that we were talking to said that the humanities are now more valuable than they used to be because of this phenomenon of, the AI can do the technical stuff for you, broadly speaking. Yeva, as somebody who sells technology education, technology learning, is that something you might think about?
Yeah, we think about it a lot. Basically, what we've been focused on is automating, like great teachers to some extent. So they can make the learning experience. So the real teachers can make the learning experience even better, right? So I think that's why I think the quality of teaching in general will go up. And and in response to the audience question, I think like the definition of the real world is going to change as well, because the way teachers teach today is kind of, just coveted in the world they live in. Just imagine they have an opportunity to relate a student to any other world that one can imagine. So I think it's a fascinating time, and a lot of kind of educational progress will be kind of, driven by teachers. The only issue there, and that traditionally has been the case, that good teaching is not necessarily where the biggest money is. So good teachers are not necessarily the ones that are, the most kind of, that pay the most. And it's also true in the technological world, it's interesting. So, and that's why I think like basically giving them more room, and just because those are the humans, those are the teachers who understand learning science, who understand psychology, who can bring the education to the next level, because what we already have can be easily automated.
Right. We have a very interesting question that says, how come we're talking only about AI and not about education? And I think there's a very interesting insight in there. I mean, it's the input, sort of the infusion of AI into education might be something we have a hard time imagining right now. So we can't really talk about them at the same time in a way. So we're going either about talking about education, and we're a bit closer with these comments about it's about the teacher, how they teach, etc. And also, I mean, we often, when we talk about teachers, we imagine the good teachers. I've come across some bad teachers, and maybe AI would have been a better teacher than the bad teacher. So also that aspect of, is there a kind of a standardization of a minimum quality level that we might see along those lines? And finally, if somebody wants to take this up, do you think that when we think about AI and teaching with AI, that our approach to pedagogy, to the way we teach, to learning theory will change? Or do you think that learning theory is so fundamental, we know how it works? Yeva is saying, no, it won't change. I imagine Hrant saying, yes, it will. Go ahead, guys.
Yeah, maybe like, learning psychology has been there forever. It hasn't changed. The methods, how you kind of teach, some things on top of it may change. But, the basics of how human brain kind of learns, as long as humans are there, I don't think that's going to change. So great teaching is a lot of psychology, and learning science is all about psychology as well. It's about the tricks, you do in the classroom that change over time. Yeah. Like you forced someone to learn, 200 years ago, now you gave me 5. So it's more fun and more kind of, so I don't think that the core is going to change, but yeah, happy to listen to what Hrant has to say.
So I'm teaching in the university, not in schools, and I think the biggest value that I bring to the students is not about the knowledge about mathematics that I teach them, but the kind of ability to look at the faces of the students and understand which part some of them didn't understand so that I can repeat, right? Because sometimes the students cannot even express, even at 20 years old, right? Cannot really understand which part they are missing, which part was hard, which part they missed. So I think that's a value that teacher gives that I still do not see how this kind of technologies can help, although I won't say that it will never happen. I don't know, maybe if there are some cameras in the room and they closely look at the faces. At some point, maybe some systems will realize which parts the face changed and maybe repeat that part again. But the current technology, I think, can change a lot in the content, in the assessment, but again, not that psychology part that Eva mentioned. So I think the teachers in that sense should switch their focus on providing this type of mentorship, this type of understanding the psychology and the difficulties of the student, and then mentoring, and leaving the content, the relatively boring part in some sense, like remembering numbers and facts and things like that to machines, because anyway, those students who graduate, they go to job market, and in their daily jobs, they will be able to use this technology. So those things that you're going to teach that can be done with this technology, they're not going to do in most cases. So I think this kind of shift will happen in the education, but I still don't see that the shift will happen in the relationship between teacher and student and the psychological part.
Yeah, I would just add, I think 100% agree with everything that was mentioned. I do think, pedagogy and teaching, that delivery, that human delivery of education is very hard to disrupt. I do think where you're going to see the most gains is actually more in just the productivity and the workflow of people in the education institution. So thinking about, as I mentioned, just the ways that you can reduce some of that admin work so that great teachers can focus on pedagogy and great teaching instead of having to write reports or have to individually pull reports of every student and grading. I think the ability to now, instead of having 1 week timelines for grading an essay, you can now get instant feedback, or not necessarily instant feedback, a 1-day feedback where the AI gives you a base and the teacher comes in and refines it and creates the final product. And so maybe I think we're going to see more disruption ultimately more in the actual productivity and admin work as opposed to the actual delivery of education itself.
Great. We have a couple of minutes left. I wanted to sneak in a question about assessment, and that's a question we have from the audience as well. Maybe Claire, are you seeing pitches around assessment using AI, and do you think that's a significant kind of sector?
Yeah, definitely. I think the vision of adaptive learning has always been a core, I think, problem to tackle in the education and ed tech space. I think historically what we've seen in, AI has been around for a long time. And so what we've seen in like assessment space has just been kind of a digitized version of how we test kids today. But as we think about just formative learning and the ability to, test kids as they're learning, I do think that there is that opportunity now. I don't think we're seeing it implemented in classrooms, but I do think you now have this ability as a person is, for example, you can think of it like YouTube. They're building out the ability to basically have an assistant on the side whenever you're watching, for example, a Khan Academy video or a crash course video, or even any of these learning content. You can actually inquire and ask the video. You can say, hey, YouTube, can you help me teach me where the part where go to the video part where I can learn about fractions, etc. And so I do think there's now this ability to actually log that type of data. And so that, maybe when the kid goes back to the classroom, the teacher knows this kid was looking at this stuff. They had a lot of struggles with this part of the video. So I do think there's now new ways of identifying skills gaps, identifying where people are struggling, because you can actually identify and capture that data as they're learning. So I think the assessment and the test as we know it is going to fundamentally change. I also do think in the higher ed setting, everybody has this question, but there's, I think, no proof that the way that we teach in the form of like an essay is the best way to assess whether a student should get to a school or not, or whether or not they've learned something. And so I think there will be fundamental rethinkings around the actual ways we assess skills and assess gaps in the education space.
Okay, great. So we're having too much fun. Our hour is up. Thank you very much for joining us from all over the world. And this was a very high quality conversation. I'm very grateful, and I hope we'll continue it offline. Thank you. Bye now. So what we have next, I guess, is a fireside chat with Stephen Wolfram, which I would encourage all of you to jump on that link if it's already running and check it out.
In charge of their own learning. That dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders. Project labs with international professionals. At Tumo, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several Tumo centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend Tumo centers each week after school. Tumo offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders. Project labs with international professionals. At Tumo, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several Tumo centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend TUMO centers each week after school. TUMO offers 14 learning targets at the intersection of technology and design. TUMO's educational software, the TUMO Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. TUMO makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by TUMO's workshop leaders. Project labs with international professionals. At TUMO, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several TUMO centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. TUMO is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend TUMO centers each week after school. TUMO offers 14 learning targets at the intersection of technology and design. TUMO's educational software, the TUMO Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. TUMO makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by TUMO's workshop leaders. Project labs with international professionals. At TUMO, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several TUMO centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. TUMO is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend TUMO centers each week after school. That puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend TUMO centers each week after school. TUMO offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders. Project labs with international professionals. At Tumo, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several Tumo centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend Tumo centers each week after school. Tumo offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders. Project labs with international professionals. At Tumo, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several Tumo centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend Tumo centers each week after school. Tumo offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. TUMO makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by TUMO's workshop leaders. Project labs with international professionals. At TUMO, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several TUMO centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come.
And education at the TUMO Center for Creative Technologies. Today we're going to have wide-ranging and multifaceted discussions about the new reality we find ourselves in, brought about by the acceleration of AI. This acceleration is exciting, it's unnerving, it's definitely consequential, it opens up all kinds of possibilities for learners. And it really ushers in a new era that we welcome and that we're a bit worried about. It feels like despite all the concerns, all the challenges, AI could now be leading us away from traditional schooling and education systems that haven't changed for a long time. And in the best case scenario, it could be helping us introduce a new kind of pedagogy into the mainstream, where the learner is in charge, where the learner has agency, and which is effective, respects their rights, and is efficient in terms of learning outcomes. Interestingly, this new kind of pedagogy that we're hoping AI will help us achieve is likely to be less mechanistic, less regimented, and more human. And kind of being human is what education is about for many of us. At the end of the day, we're in the business of educating young humans. I'm not saying humans are better than other people, but nevertheless, that's what we work on, and that is at the core of what we do. And being human is something that needs to be learned and sometimes relearned. It needs to be nurtured and protected. And part of being human is getting into trouble. Ingenuity, curiosity, ambition, these are traits that we value as human traits, and we value in education as well. But they tend to, at the end of the day, cause some kind of mischief or transgression, which we have to deal with a mixture of annoyance and admiration, or sometimes with existential dread, which drowns out any admiration we might be otherwise feeling. And this has been going on for a very long time. Ever since the myth of Prometheus, and definitely before that, Prometheus stealing the fire from the gods, this was the norm. Happens again and again, and it looks like we've done it again with AI. We've gotten ourselves into a very interesting kind of trouble. And that kind of trouble we've gotten ourselves into feels a lot like playing with fire. Because this time, it has a lot to do with human language. With large language models, we seem to have cracked the language code, as well as visual language with things like diffusion models. And we've been told again and again that language is a defining feature of being human. I don't know if that's absolutely true. It might be inaccurate. Still, the fact remains, synthesizing language is like playing with fire. And we hear this a lot, that AI is like playing with fire, power, bad. I'm not a big fan of that analogy. I prefer the alien metaphor. I like to see AI as an alien, and in the first place, an illegal alien that's here to, we fear, take our jobs and alter our society and our values, and that represents a security threat, for example. As somebody who's been an immigrant in multiple countries, I think we should be more self-reflective about that reaction. But also, AI as an extraterrestrial, as a non-human intelligence, as a kind of a foreigner in that sense, is another way we've looked at AIs as aliens. And even there, I think we need to think deeper and more carefully. What is it about, let's say, foundation models that is not like us? I mean, they certainly talk like us, they draw like us, they hallucinate and make things up just like we do. And when we ask them to do reasoning tasks, their performance is very impressive, and all the more impressive because they make the same mistakes that we human learners make and that we learn from. What is not very human is the way machine learning models are trained. Of course, the way a neural network learns, for example, is very different from the way humans learn. It's almost like taking rote learning to its absolute extreme in an inhuman way. But maybe we can imagine a more human-inspired kind of machine learning. And maybe that needs to be more socially integrated, more about discourse and dialogue than rote learning. Now, this sounds like science fiction, and I think there is a point to be made about welcoming AIs into our classrooms, not only as tutors and as teaching assistants, but as students to learn with us. But let me make that a little bit more specific, a little bit more narrower, but still remaining within the realm of being inspired by science fiction. And I want to talk about The Diamond Age. The Diamond Age is a sci-fi novel by Neil Stephenson, published 30 years ago. At the center of it is an interactive book that is a teaching AI. It's destined for a lady from a very wealthy family to educate her, but it somehow falls into the hands of a very underprivileged young girl. It helps her survive, educate her and develops her, and helps her rise out of the slum where she lives. Now, this young lady's primer, young lady's illustrated primer, which is what the book is called in the novel, was one of the inspirations behind the Tumo Center when we created it 15 years ago. And the way it works is very different, as described in the book, from what we've come to know now as AI chatbots. It's not about correcting mistakes and giving the learner knowledge or helping them generate text. This book, this Teaching AI, has a pedagogical strategy. And if we're going to create a system like this, it would be trained not on text and images and annotated data, but on the experiences of learners, what they prioritize, the learning moments that they value, the experiences of teachers. So we would learn from teachers, which is what we do, and from learners, which is always very effective. And we would develop a system under this scenario which has a theory of learning. It will have internalized and learned a theory of learning, and not just a way of producing text or language or knowledge. So the best thing that I think can come out of our discussions today is really a community of technologists and educators who will be inspired to come together and to really bring AI technology at the service of human flourishing, and that can be ambitious enough to use machine learning technologies at the very core, not as an added layer, but to actually train and develop models that are all about a theory of learning and the pedagogical strategy. So for the rest of the day, we're going to have a wide-ranging discussions that will touch on multiple aspects of possibly this project or other projects that will emerge from the conversations. I'm sure that each discussion will spawn a thread of conversation, and that's exactly what we want. But we're going to start first and next with a real treat, with one of my favorite economists, Daron Acemoglu from MIT, being interviewed by one of my favorite people, Emerson Collective CTO and Director Rafi Krikorian, about the power dynamics of AI, about how there's a danger that technologies like AI being introduced into society, in addition to eventually bringing a lot of prosperity and progress, can also concentrate power in the hands of the few at the detriment of agency, in this case for the learner, which is the opposite of what we want. So, welcome again to our symposium on AI and education, and let's enjoy the interview with Daron by Rafi.
I mean, I just have a few questions, but I figure we just chat for 15 minutes and then we call it a day.
That's it. That's great. That's good.
Maybe one of the things I wanted to start with was like, I mean, the core idea behind Power and Progress, if I understand it correctly, is that technologies like AI create a dynamic that concentrate power in a few people's hands, and then therefore has a depressing effect on wages, has other societal harms, large segments of society become at a disadvantage. However, mechanisms like regulation, civic action can maybe shorten or ideally prevent those periods of that which happen. Given that, and given all the things that are happening with AI right now, I'd love to get your sense of like, what's the role of education, especially in that AI, in this like AI world that we live in now?
Well, I think, thank you for summarizing the main idea of the book. Indeed, I think the main emphasis of the book is that there is no guarantee that any technology, even those that are very promising, such as AI, will necessarily bring shared prosperity. So we have to work at it. And they could become concentrated in the hands of a small group who may then use it for displacing labor, reducing the role of labor, and creating monopolies for them, or monopolizing information in the case of AI. And so we have to find institutional and technological solutions to improve the prospects of society at large in the face of these types of disruptive technologies. Now, education, of course, has a very important role, but I hesitate in jumping into education as the main solution,
Okay.
partly because both within economics and in policy circles, for the last 50 years, we've heard, oh, technology is running ahead. The only thing you can do is education. And we don't agree with that perspective. First of all, education is only one of the tools. And second, the perspective that technology is going wherever it is going, and we have to educate the workers differently so that they can adapt to technology, though it has some grain of truth, is too one-sided. We have to make sure that technology also is appropriate and develops in a way that's coherent with the skills and priorities of the workforce. So it's a two-way race in some sense. And so I think that's one important aspect. Now, if you look at it from the point of view of developing nations, however, including Armenia, I think the problem is more complex because you have to first adopt the technologies and make sure that your workforce has the skills to be able to adopt, bring, and utilize that technology. And then you have to worry about how that technology is being used, how that technology is being developed. So for developing countries, I think education is more important because the danger is that they'll fall behind in this process. So many developing nations, many emerging markets are very behind in the AI process because they're not ready for it. Their organizations are not ready for it. Their education system is not ready for it. And quite honestly, their politicians are ignoring all of the opportunities and the dangers that AI poses for them. And for example, for Armenia, I think has some enviable and some really unfortunate positions at the moment. The country is suffering still from a variety of geopolitical and economic problems, and in political problems, some of the most skilled Armenians have left the country, and that trend doesn't seem to have completely subsided. But on the other hand, Armenia does have a good education system. Going back to the Soviet times, it was an education system that try to prepare Armenians as engineers, scientists, mathematicians, and the influence of that history is still there. So Armenia has a great position to play a leadership role in the emerging world in AI technologies, and for that, of course, the education system will be critical.
Okay, so maybe we can separate out education in two different forms. Like there's one, which is we need to educate everyday people. We need to educate politicians. We need to educate those. But how should we be thinking about, and let's assume we can do that. I mean, that's hard, but let's assume that's a given. Then what do we need to be doing with students, both in the sense of like preparing them to use the technology, but also be more mindful about how these technologies, so like when they become builders in the future, that they're already starting to think about these.
You got it exactly
issues.
right. You got it exactly right. It's a really multi-layered problem. One is the education of the public and politicians, and that's a very high-level thing we don't want. I mean, it's okay if politicians become good at prompt engineering, but that's not what we are aiming at.
Yes.
We want them to understand the capabilities, the dangers, the ethical questions involved in AI. For the students, I think there are a couple of important issues and important dimensions. First, we want the vast majority of the students to be comfortable with the technology. So that requires them to learn some basics of artificial intelligence, including prompt engineering and how to use some of these new tools that are developing, some of the do's and don'ts of using these technologies, having enough of an understanding of the background from computer science, from where knowledge is coming, where reliable knowledge is coming, so that they can be good and socially mindful users, while at the same time have the skills and the knowledge to create good opportunities in the labor market for themselves. Second, we want all of the students to be aware of what are the types of skills that are going to be in demand in the labor market. So if the students don't have the knowledge of which types of jobs are likely to be eliminated and what types of skills employers and the community in general is going to demand, I think that's not going to be good for them. So the evidence from the US is there's certain jobs that are not going to be hiring as much. For example, if you are doing very routine knowledge work like collating of information, accounting, account keeping, etc. So I think we have to prepare the students for that. On the other hand, we know that a lot of creative tasks, both in the entertainment industry and the knowledge industry, are going to be still in demand. We also know employers want much more flexibility. They want a lot of social and communication skills because humans are still going to want human interaction, but that's where social and communication skills become important. So I think that knowledge has to be imparted to the students, and they need to get ready for that new labor market. Finally, for a small minority of students, they will have aspirations and skills to be at the cutting edge of becoming engineers or designers or computer scientists, and we need to make sure that they get the necessary background so that they can be competitive with the students anywhere from China, from the UK, from the US, who want to jump into that race as well. But in that, it is also very important to provide that holistic picture so that when they become users of that technology, when they become employers who depend on that technology, when they become designers of that technology, they know what are the socially responsible and ethical choices, where the pitfalls are. And I think that requires something much broader than technical education.
So maybe we can talk about the educational system overall for a second. If I remember correctly, like something like 9-10 years ago, you wrote this paper which said that the internet has this ability to completely disequalize, like there's going to create superstar teachers effectively. But you also posited that it was possible and we needed to create a system to actually try to equalize that again.
Absolutely.
Is that going to occur again in AI?
I think it is. It is.
And how do we then stop it?
It happened a little bit with the internet, the massive MOOCs, the massive online courses, for example. Things like Khan Academy that started taking away some teaching tasks. But the basis of the slight optimism of that paper was the belief that most students, the great vast majority of students, need other humans to be taught. So you cannot have an education system that's purely online. And that remains true. And I think this is going to be both an opportunity and a pitfall for AI, because that's a lesson that I think the AI community has immediately forgotten. And many people within the tech world are still working on things that do not leverage the skills and the importance of teachers. So again, online courses on automated grading, automated teaching, self-teaching, those have their role, but they need to be complemented with teachers. And I think what's missing is AI tools that will make the teachers much more skilled, much better, for example, in personalized education, customizing the curriculum for the real-time difficulties and needs of the students and the diverse students. This is very valuable evidence shows for example, students from low socioeconomic background. So it is exactly the kind of tool that could create an equalizing effect. So I think this is the space where we need new technologies, but also the teachers to get ready for AI. The teachers can ignore AI. That's not going to work. I mean, we know, for example, tens of millions of students in the US and hundreds of millions around the world are using ChatGPT already. So ignoring those developments would only lead terrible outcomes in terms of what homeworks, what classroom teaching, etc., are going to lead. They can try to block it. I don't think that's going to work. So the teachers need to adapt to it. Their norms, their rules are going to have to change, but the teachers themselves, their skills and their teaching methods can change as well, together with the right technology.
So what you're basically saying is that instead of focusing, I mean, it's not black and white. I hear you on that. Instead of focusing all our time and effort on basically direct to students, we also need to be making sure that we're providing teachers the tools to make them more effective, efficient,
Absolutely,
like amplify
absolutely.
the humanity of teaching.
Absolutely, and that is critical for the teachers, but it's more importantly, I really don't think that a a school system, an education system without teachers playing a central role would be effective.
I'm very thankful for your time. So maybe one last question before I'm just curious, given your writings, given your thinking, and given the world we live in, what gives you optimism? Like, what are you optimistic about?
Well, I think two things I'm optimistic about, but extremely cautiously. One is that we have been here before. The book I wrote with Simon Johnson, Power and Progress, is very historical precisely because we've been here before, and there have been episodes in which we've made the wrong choices and technologies have been bad for society or for many people in society. And there have been periods in which our institutions have adapted. People have risen up when the technologies were used against them, and better outcomes were obtained. So I am very optimistic that we have it in us to remake society in a way that can benefit from technology in a fair, equal way. I also am optimistic that the new technologies are very capable and they have the potential to be very pro-worker, pro-humanity, pro-democracy. So it's not true that AI can only work with authoritarians. It's not true that AI is going to destroy all jobs. So that potential for helping workers is there, but very, very cautiously optimistic, because I think right now we are both politically and economically at a point in the United States, especially, where the tech industry has the wrong direction and is very powerful. So changing course is very difficult.
Darren, thank you so much for your time. Thank you for showing up and supporting Tumo. I really appreciate it.
Thank you, Rafi. It was great talking to you. Thank you.
Hello, everyone. Thank you for joining us on our panel today. This one was Living with AI. My name is Rafi Jordan. I'm the CEO and Collective. I'll today's conversation. Start talking to my friends here on the screen. We have a pretty fabulous group of people here to join us for this discussion. I wish they could be here in person. Tumo Yerevan is buzzing with excitement this morning. But we have a truly global group of people. We're covering a whole set of different now a lecturer at Stanford University of Graduate Engineering, and she thinks broadly about supercharging their work. Tessa, thanks for joining us this morning. We have Joel Lehman from Stochastic Labs. Joel is a machine learning researcher, previously a team lead at a team co-lead at OpenAI. He's interested in creative algorithms, reinforcement learning, AI safety, and the intersection of ML and psychology. He was the founding member of Uber's AI Lab, employed #1 in human intelligence, and former professor at the University of Copenhagen. He's a co-author of a very popular science book, Why Great Minds So we're very lucky to have him today. Next up, I have a friend of mine, Cynthia Brazil from the MIT Media Lab. She's a professor of media arts and sciences at MIT, where she founded and directs the personal robotics group at the lab. She's a leading figure in the field of social robotics, human-robot interaction, and the author of the pioneering book, Designing Sociable Robots. She also serves as MIT's Dean of Digital Learning and is the director of the MIT-wide initiative on responsible AI for social empowerment and education. They work on offering global programs in K-12 AI literacy. And then finally, I have So Young Ro from the Art Center of Nabi. She is the pioneer of a new media art scene in South Korea. She founded the Art Center of Nabi in Seoul, where she's organized multiple exhibitions and research projects at the intersection of robotics and the arts. Her trailblazing project, My Fair Robot, presented research on social robotics at the Future Fest event organized by the UK National Endowment for Science, Technology, and the Arts. So we're very lucky to have everyone here today. We have a huge range of topics that we could possibly cover, so we'll just kind of see where the conversation takes us this morning. But maybe what we can start with is sort of like as a framing question. I think we can all agree that AI has sort of been with us for a while. You know, we spent the morning here at TUMO talking about how generative AI, this new wave of AI, has captured the popular imagination, but AI itself has already been part of technologies that we all live with in our day-to-day life, whether it be our cell phones, whether it be the way we transport around cities. But AI has sort of been everywhere, and we can also agree that AI will continue to be with us for the foreseeable future. It's probably this coexistence of humanity and AI is kind of how we look at it right now. And this is poised to be an extremely transformative thing for our societies and for the world. So where I want to start with, and maybe I'll start with Tessa, sort of like maybe either from the work perspective or just from the broader society perspective, is what advice do you give people when they're when they're trying to navigate through this like complex set of issues, whether it be is AI going to kill us? Is it going to take away our jobs? Is it something I'm going to be interacting with every single day? Is the movie Her real? Like, what advice do you give people as they sort of just try to think about how to embrace this?
Yeah, that's a great question, and I definitely once had a dream that the movie Her was real, and that was terrifying. I think one of the most common questions that I get at is AI going to take my job, and what will that look like? And I think that's a pretty reasonable question, because on the flip side of that, a lot of executives that I work with are asking us, how do we use AI to drive efficiencies to take people's jobs? So it is a really interesting question. I think my biggest piece of advice is not to make rash decisions just yet. I think that especially with generative AI, there's a lot that we don't know. There's a lot of potential unintended consequences and implications. And instead to think about how we can use these tools to productively automate or to help enhance human capability and potential. And at Next Level Lab, we do a stream of research that we call intelligence augmentation. And that's really looking at this. What are the skills that humans need to be able to work with artificial intelligence tools in a way that helps them be supercharged and have power and not necessarily lose their job due to AI, but change what it looks like and do it more productively.
So there's that theme of automation versus augmentation, of just like that's like, if we maybe the follow-on question here is like, is there a way for us to embrace one or the other? Is this inevitable and we just need to sort of understand it as it's coming toward us?
Yeah, that's a good question too. I think that it's very, I think that it's inevitable that technology is going to continue to proliferate and become more powerful. That to me is inevitable. What isn't inevitable is how we respond to it and how we react to that thoughtfully. And so taking a position of augmentation means that we're saying human skills like judgment, like critical thinking, like ethics and empathy are all still essential. And we need to figure out how we use them and marry them with the benefits that AI give us, that the automation gives us. And so from my perspective, I think we'll have a much more cohesive and less turbulent journey if we also respect the role and the unique skills of a human in this journey moving forward.
I mean, Joel, maybe I have a similar question for you. I mean, you were fortunate to be working at one of these organizations as is creating some of these tools that's causing us to ask all the big questions that we have today. I've been wondering from your perspective of like, how do you think about sort of like this intersection between how technology is impacting our lives? What does it mean for what it is to be human in this world?
It's a deep question.
Only deep questions.
Yeah, so I'm no longer at OpenAI. I don't speak for them, but I can kind of speak to my experience while I was there. I guess a couple of things. I mean, one is that the vision of people that are working at some of the tech companies that are developing these technologies may not match the vision of kind of most people in the world, and so just that kind of gap is something to kind of keep note of. So just there's a kind of a narrative like at OpenAI and other companies kind of like about the coming AGI future, which may or may not happen. But there's a certain like a real vision there. They hope to make that happen, and that's a kind of a strange thing when talking about just your daily life and kind of the ways you're approaching everything that's going on. I guess the other thing I would say is that the technology is currently moving fast, and there's a lot of both hype and real potential to the technology. And even as an AI expert, I still get pretty overwhelmed by what's real and what's not in terms of where this thing is going, and if we're going to hit a brick wall at some point, or whether things will continue to kind of ratchet up. And I can only imagine, from the outside, not being in this world must be even more confusing, and all these different competing experts telling you different things. So I guess there's some compassion coming from the side of the table, and it's the advice, I think maybe similar to what Tessa said, is that the skills of critical thinking and reasoning are, I think, going to be ever more important as the generative AI stuff kind of pervades our society more and more.
I want to talk about some of those themes in a bit, but let me first turn to So and Cynthia for a second. I mean, you both have been working at sort of already this intersection of machines and society for a while, right? You've both done robotics, and robotics is sort of that canonical example now people can look back to of just people interacting with a machine, not just this chatbot on my screen, but physically doing it. What lessons should we take from that as we sort of go into this world sort of moving forward? Maybe I'll start with you for a second before we go to Cynthia. Sort of given your work, your art that you've done, what lessons should we be taking?
Well, I've been working at the intersection of art and technology in general, and robotics was one of them. We started working with robotics since 2012, so it's been over 10 years or so. We're still doing R&D and experiment with various types of physicality of it. At one point, I made a big teddy bear, because I insisted on the fur, because we react to fur kind of thing. We feel that's why we have fur pets. But then I ended up burning the motor 3 times, so I realized why people do not use furs. I'm sure Cynthia will have something to add to it. But physicality is important, and we talk about AI, and there's a limitation that AI can do. AI can think for us, but unless it's married to something physical, and it cannot act also for us. I may be wrong, but that's how I think. Cynthia?
Cynthia, I'd be curious to know your take on it too. I mean, my children have played with some of the robots that you've built, and you can sort of like watch like what happens as their like imaginations gets captured by a machine effectively talking back to them or interacting with them. What should we learn from that going into this world?
Yeah, so I guess I'll start by maybe answering a little bit of the first question and then move into your question. So I feel like when I talk to the public in general, AI is often spoken about like this sort of sentient ether that does stuff to us. And the reality is we make it, we design it. It takes a lot of human talent and engineering and effort to make it do what it does. So how it interfaces into our lives and society is still very much in our control. So what is our vision and our intention of that? I think it sounds like I'm going to echo what everyone else has already shared, which is AI should really be something that augments, enhances what we as people do, right? We have our values, we have our sense of what are the important issues, we understand human experience. So the first thing I would say is, there is an opportunity and a continued challenge for how do we really design these technologies to support how we solve problems, our human experience, so that it helps us to become society we aspire to become. It contributes to human flourishing. There's a much bigger, I think, it out there that we can be striving for it and understanding it is up to us to design that. So in my own work, there is how do we design AI itself, the computational intelligence, the algorithms, to really be able to dovetail into how people think, how we experience the world, so that their behavior with us is not only natural and supports how we do things, but hopefully even elevates. So my work was one of the first, in the early, 2000s to say the social and emotional intelligence of AI is actually really important for its ability to dovetail with us and enhance and support what we do. And now that ChatGPT is out there and people are like, oh yeah, social intelligence is really interesting and important. So, we've been seeing and doing this for like decades. So yes. The second bit is we need to prepare society, right? So, we had digital literacy and digital citizenship, and AI is changing all of that. So as part of my own research program, as we're designing these social robots and setting them out in the world and studying how people interact with them, it's like, oh my God, people have no idea how this stuff actually works. So we started to build a whole program around building an AI literate society so that we can demystify what AI actually is in an age-appropriate, grade-appropriate way. We're MIT, so we love having people actually learn about it by actually putting them in the designer seat and making things with it and teaching them responsible design skills and conscientious use of these technologies, and to empower them to be actually able to make things with AI that they can see how they can make a difference in the world. So not that AI is this thing that is happening to you, but you at all ages can start to understand and harness this so you can make the world that you aspire to see as well. So the AI literacy piece is becoming increasingly important. And then the third thing is, again, we need to understand how to design these technologies. What are the right knobs? What are the right interfaces so that we as people can have them much more directable and understanding what our intents are and shaping its behavior. So I would call that we're starting to design a lot of responsible design frameworks for people who are creating these technologies. Because often, it's the same way we still educate a lot of our technical people today. They're not trained in really understanding principles of design justice, what are the issues, the ethical responsibilities of these things. But the more we can have everyone share that understanding of those design frameworks as we tackle these problems in the future or now that are very multidisciplinary, require teams, of people with different talents and skills and perspectives, the more they share that foundation, I think the more effective we're going to be in coming up with solutions and tools and experiences and technologies that actually serve our values. And we got to monitor it, right? We got to monitor it to make sure that it's actually doing what we intended to do, because sometimes these are complex things. Sometimes what we intend isn't what's happening. So you have to keep on top of it. So just having people understand that when you deploy these things, how do you integrate them? Not just deploy, not just setting them up, but how do you integrate them into the human networks, the human technical ecosystems, to make sure they are actually serving a valuable role and doing what they need to do to, again, support what we as human beings in the society are hoping that we can achieve in better ways now with AI. So I don't know if that's lessons or advice or whatever, but that's kind of how we are framing kind of the kind of full spectrum of how we feel we need to prepare people for this increasingly world of AI powered and now generative AI powered technologies.
Thank you for that. You've touched upon a bunch of stuff I want to talk about, but like it's maybe the meta point for me is that there's a lot there. And like we're both competing with, we live in this world where like every day feels like a year right now when it comes to technology being deployed. So we're also competing with the speed at which everything is moving. Look, I mean, like I showed my children ChatGPT when it first came out. My children are 7 and 10. They weirdly thought it was, weirdly for me, weirdly thought it was normal. They're just like, of course a computer can do that. But then you show it to my mother-in-law, who's in her 70s, and she also weirdly is not impressed by the power of what's going on. So like how, I mean, maybe these are 2 data points, maybe I'm overgeneralizing, but if we live in this world where like people have just accepted technology does certain things, and we've all now highlighted that like people need to understand it more, people need to lean in more, there's agency that comes from it, there's like these complex interactions in this socio-technical thing. I mean, maybe I'll turn to Tessa, you first. Like, how do we sort of compete in that world of like, what do we need to do to spark people to even start thinking about this broadly, let alone make sense of what's going on?
Yeah. I mean, I think Cynthia really touched on an essential point here, and that is empowering people to understand how AI works, and using an explore before explain model is ideal. I'm all on board with that. At the same time, there's 7 billion people in the world, and not all 7 billion will be afforded the opportunity to do that. And a lot of our society will just be in a situation where they're interacting with AI and with the various different types of AIs, and probably already are. They don't necessarily understand it, nor do they have people around them who understand it. Joel, you sort of said the other side of the table, so to speak. And I think that it's really important to have empathy and compassion for what that must look like, and for us to think about for those folks, how do we help scaffold the interaction and what it looks like. And so one thing that comes up a lot for me, and I think is reminiscent of your 70 and 7 having the same reaction, is that is also what's happening sort of in universities right now, where some institutions are saying you can't use ChatGPT in any way, and same in a lot of companies. And part of I have quite a visceral reaction to that, which is, well, they're going to. So this is a little bit like teaching abstinence, is what you're saying. Like, I think that actually what we need to be doing is really teaching, okay, here are our guidelines, here are our policies, here's how we want you to think about use. What are the metacognitive kinds of questioning and activities that we want you to be able to engage with to determine if something is real or reliable, and sort of teaching like its place and its use. I think is a really important thing for us to do, because that reaction of, oh, well, of course technology can do this, of course a computer can tell me that, is concerning, because that also, I think, implies that there's trust, and perhaps that trust isn't deserved. And I think that's where we know with hallucinations, with large language models and things like that we're starting to see that you can't trust it to write your legal brief for you. You can't trust it to write your essay. You can't trust it to tell you that the 3rd president of the United States was a woman. Like they're not things to believe.
Joe, I want to welcome you in, because like when word trust came up, you started nodding vigorously, and so like I just want to get your take on that word trust as well, as it comes to these systems.
Yeah. I think I was nodding vigorously because it's just something I'm afraid of, which is that as evolved creatures, we're pretty influenceable when it comes to like granting agency to other artifacts and ascribing to them powers or potentials that they may or may not have. And I know there's lots of people working on this, but it'd be beautiful to have
these values, these things that we do want to take agency around as these technologies are being built around us?
Well, many artists I know are very busy learning these new apps, APIs, and there are almost new ones every month or so. And I mean, there has been a lot of talk before the whole generative AI stuff came out. The notion of agency, where do we stand in terms of machine and human beings, and now it seems we've forgotten even to think about that. We don't even have time to think. And then, but I do want to mention there is something we call it GPU poor. In my country, still South Korea is very advanced. Our IT infrastructure is very advanced, but we don't have Google data center. So when using, new AI, what do you call it, models, we are oftentimes very frustrated. Doesn't work. It's delayed and stuff. So there's the issue of infrastructure, hardware, and the network. The issue of that should be addressed. The difference between New South and New North, and the whole notion, the war around the chips and all that. So it relates to the instant while this artist had no notion of where we are. We're not generally interested in geopolitics or political economy of the world, but while we are trying to make something, then we confront this lag and frustration, and we notice that, we don't have the data center, and we're so where are they? We used to say, we don't have enough data, but it's not anymore about the issue of data. But your question was not about that. You're sorry. You were could you rephrase it?
Yeah, no, I'm wondering, I think we're all in agreement that we need people to be better aware of how these technologies work so that we can be part of the conversation on how they're deployed, used, trained. Mm-hmm. And so my question, one aspect, I'm sitting here in a center full of thousands of children right now who are all doing education. One aspect is we can go teach all our kids. I want to talk about that at one point. But what's the role of culture in helping us, culture to help our society also figure this out? I mean, we've been faced with movies such as The Terminator and others that sort of paint these technologies in a very specific light. So how do we then use this massive lever to sort of like get us all on maybe this more positive page?
Well, I have no idea. I think we're seeing right at the moment a new unfolding of a new culture that is happening with the help of this new technology. So it's called generative AI. So we don't really know where it takes us, to be honest.
I mean, it is one of the things that I wonder about, just like how do we get us all into one page? So maybe let's go to the children question for a second. I know, Cynthia, you've been thinking a lot about, like with your Day of AI and other efforts on how do we educate lots of people around this technology so we can try to unify them maybe on values or et cetera. I wonder if you can give us some thoughts on how we should be continuing to do that kind of work.
Yeah, so thank you for that. Just to frame it in the much kind of bigger picture, I think all of us on the panel would like to see an equitable future with AI. It doesn't exist right now. It doesn't exist in the United States. We know there's huge disparities, social economic class and so forth. Across the world, it's Northern Hemisphere dominated, right? China, United States, Europe, and then we have, the global South. In a program like Day of AI, just to communicate that there is deep interest and concern, I think, by countries all around the world of not being left behind on this new AI-powered wave. And there's an acknowledgement that they need help to be able to bring their citizens into that world. So one way we can reach a lot of people is through the K-12 education system, right? So our Day of AI program, it is a teacher-oriented program, meaning that we do professional development for educators to be able to bring short format right now, artificial intelligence curriculum, which is multidisciplinary, it's hands-on learning. It talks about, demystifying the algorithms, but also talking about the societal implications and encourages critical thinking. So we're trying to foster all the kinds of skills starting from K-12 around this technology. And, we started, this program's only been in its second year. We started our first year thinking, okay, we're just going to do United States, kind of crawl, walk, run, whatever. And we were already in over like 90 or 70 countries in the first year. People were just organically finding us and wanting to use this curriculum. The second year, we've more than doubled. We're now in 114 countries. And I have organizations who, want to bring these materials to every school in like countries now. So just to share and communicate the deep desire of the world to try to understand and prepare their society for this increasingly AI-powered future. So we have a real opportunity, and also how do we think about educating, at least starting K-12 students, about this technology in a way that we think will really help prepare them for this future that they're going to be living in, right? So one of the great things about AI is that it's kind of in everything. So your curriculum can actually be multidisciplinary because AI is kind of the glue, right? It can be very hands-on and creative design, creative problem solving, right? It can be, we talk about plugged activities that require technology. There's plenty of unplugged activities we also design. So I think we can be very innovative in how we think about bringing these kinds of learning opportunities to the global stage, where we also really empower teachers and those regions to then say, we admittedly have designed what we've done with the United States lens because we're in the United States, but it's Creative Commons open. We want to form relationships with you so you can localize and translate and make this super relevant to your community. And we're seeing a lot of that uptake as well. It's for all teachers. We say AI is for everyone. Any teacher can teach this curriculum. And it's just about kind of being aspirational, I think really innovative at how we try to, pull the levers, as you said, Robbie, to help create much greater equity about this technology worldwide. So that's like one kind of thing that we're looking at. I mean, of course, the professional development and so forth, that's also very, very important. But the great thing about school systems is you actually can reach a large swath of a society by, and children, of course, They are fascinated when we talk about things like around how you can make a difference with these technologies to solve the problems that matter to you. They're engaged. I think young people these days, they want to make a difference, and these tools are realities, right? Kids can use ChatGPT. Kids, through things like App Inventor, as you know, Robbie, can create mobile applications. Kids can actually today make things that can help make their communities better. So we can start thinking about, well, how do we create learning experiences and opportunities to give them that ability? Because that gives them hope. It gives them a sense of they can really shape the future. I think, again, we can just be, I think, very innovative in how we think about this particular topic, because it's like a blue ocean, right? It's not as if there's an already AI curriculum. It's like we can really design it very thoughtfully about what we think young people and teachers should really be able to know and do with these technologies. And again, there's a real hunger and desire worldwide.
I mean, speaking from Yerevan, which is maybe, you could define it as the global south or maybe the northern end of the global south. Like, I think there is like a real hunger and desire to also be part of those conversations. So it's not just purely the United States and the Western world sort of like dominating what that looks like. Tessa, I want to bridge this over. Like, if we talked about kids for a second, let's talk about adults and maybe job retraining. And like, how should we be thinking about that? Like there's one sense, like if we go back to the automation versus augmentation debate of just like teaching people to use tools in order to make themselves more effective, better, etc. We could talk about that. But there's also inevitably going to be some workforce turnover, as sort of like, which has happened every single time some kind of transformative technology lands. I mean, these are two really big questions. Choose whichever one you want to start with, but we could talk about that for a bit. But I'm curious on that impact on the adult side of the population too.
Yeah, I think it's interesting because I think in the adult side of the population right now, a lot of folks are sort of feeling the impact of generative AI right now before they've had a chance to participate, or it has become a more equitable distribution of decision making and design, which I completely agree, Cynthia, is the way forward. But a lot of folks are feeling right now the impacts of these technologies. And so one thing that I think is becoming increasingly sort of problematic, and bear with me here, but is that individuals in sort of what we would traditionally call middle skills roles are quite often impacted. And if any of you have sort of read anything in the last 10 years, every major organization, WEF, OECD, all the big consulting firms, they come out with a perspective of here are all of the jobs that are going to be disrupted in the next 10 years. And they publish it everywhere, and it's beautifully graphically designed, and it's glossy. And guess what? Now we're at the 2023, 2025 range where a lot of these predictions are supposed to be coming true, and they're wrong. And nobody put, copywriter or creative writer on that list. Nobody put graphic designer or marketing professionals on that list. And nobody is being held accountable for their beautiful quantifications. And in an analysis that I'm doing right now of all of these predictions, we're seeing inaccuracies of around 70 to 80% of predictions, which is pretty profound. And so what this sort of teaches me is that like this labor economics view of human capital and equilibrium is maybe not the most helpful frame for us to be carrying in how we think about this problem. And instead of thinking of humans sort of as human capital with a skill set that if they get made redundant or it disappears, they're now redundant or at a deficit, we need to start thinking about the spectrum of skills that people have, how we can transfer, like cognitively transfer skills from one context to another, engage in like micro upskilling or recontextualization instead of sending them back to a community college program or a workforce development program or a very expensive 10-week corporate run boot camp, like every time something becomes redundant or changed. Because predictions are wrong, we need to be agile, we need to sort of practice that, I think, and instill in our workforce that you are not the thing you do right now, and that if it goes away, your entire identity doesn't just disappear. Because what we're seeing in communities where, like where the General Motors factory is closed, and a lot of people were sort of made redundant and then told, oh, your job disappeared, you have to start at zero right now and learn a brand new thing, like a correctional facilities worker or a electrical pole installer, something like that, is that there's significantly higher rates of suicide and antidepressant use in those communities. And that study's been recently replicated in the Nordics as well. And so this is people's lives and emotions and life, right? Like we have to really start thinking about also changing how we talk about this sort of jobs impact, I think.
Well, I mean, that begs the question, then how do, I mean, so, you know, and I think what I'm hearing from you is that a lot of people find themselves defined by their work. They're defined by this is a thing that they do. And what you are trying to portray is that we need to get to a place where people are more resilient. Like the only thing constant is change, especially in the world that we live in now. And so people need to be more resilient in front of this and find, I mean, this is the big problem. They need to find themselves in a way, they need to redefine how they think of themselves and their value to the world. So I'm curious then, like, you know, I've spoken to a lot of artists and creators around these type of technologies. Like I spoke to a whole bunch of people around the Hollywood strike, for example, and like they have a very particular viewpoint on like how these technologies intersect with the creative space. How should we be, sorry, I don't even know who I'm directing this question to, but like maybe Tessa, I'll start with you, maybe we can go to So after that, but like how should we be thinking about both that like redefining of self and sort of like how should the creative class, how should a creative class be thinking about it too?
So I'll take the first part, and I think So is probably much better positioned to take on the second. But how do we think about a redefinition of self? I think it's a great question, and an essential component of that is K-12 education, is empowerment, is teaching that you don't grow up to become a thing, you grow up to become a person, and that as a person you have many different dynamics. But an essential component is actually enabling and encouraging employers and policymakers to see that. Because while we talk about labor the way that we do in our society today, no matter how much empowerment we do, it's sort of, you know, there's a discontinuity there. And so I think that it's essential that we start really, really thinking about people as a multitude of things, as having a multitude of skills, as employers need to see the benefit of having adaptable workforces who can change and shift on a dime and invest in developing and training that, which is not as sexy as investing in developing and training a particular new programming language that they'll get benefit from tomorrow. So yeah, I think there's both the changing in the sense of self, but also the changing in how the self of the worker is perceived more largely.
So that second part of the question on the creative class and how they should be thinking of themselves through this change as well. I mean, again, sitting at TUMO is literally called the Center for Creative Technologies. So like how should all these kids who are sort of surrounding me think about that, how their creative lives moving forward?
It's hard to tell at this moment. We are too early to tell what, how this new technology will take us and where we'll be, say, in a year, maybe a year after. We're at a very early stage. We're all happy with the wonder of this new technology, busy learning this new technology. But I do notice that this new AI, especially generative AI, enables just novice to jump to a level of a professional or semi-professional, just, very suddenly. So it's very equalizing that way. So in that way, you can say it's democratizing because skill levels just become equalized. But it's much harder. It used to be without this technology, it was very hard for a person starting from, if you're a painter, drawing, and then if you want to get to a certain level, it takes, more than 10 years. Now you can do it instantly. But then now it's the opposite. It takes just the instant to get to a certain level. but how to differentiate it with the others, it's very, very hard after that. So, after these democratizing, equalizing technology, how to differentiate yourself. So in that sense, your sense of self and self-identity has become more important. And I like to go on further to the point that it used to be there was this knowledge world was a world of objectivity. Mm-hmm. There's this objective world, and there's this private world that's subjective. Now it's become all intermingled and become more sort of knowledge. It seems to me become like a hybrid between objectivity and subjectivity. You talk about the culture, and I couldn't really answer it because now the culture, you can't really say what culture is because it's so varied and so diversified. But one of the cultural element that is very striking is that the thing called influencer, people, and then I meet them, and these young people who, renowned influencers, and I ask them, what do you do? And nothing. they just wear their clothes and they just live and go to work, but they are influencers because their subjective world says something to the masses, something different. So subjectivity, your own self, has become has gained more value, so to speak. So I don't know how to educate the young people. If you ask me, I don't know why I'm in this panel because I have no idea. But one thing I could say is, and I'm not a teacher myself either, but one thing I would say is I would do is to instill self-confidence. That's the basis more than ever, because your own sense of self and subjectivity is the basis, and it will take you a long mile, give you a mileage. That's all I can say.
No, I really appreciate that. I have some questions coming from the audience, but I need to sneak one more question in, maybe a combo of Joel and Cynthia for one last question. It's hard to have a conversation about AI in our society without talking about things like data surveillance, data collection, and items around that, of like extractive uses of our society in order so we can train these systems. But again, thinking about like what we should be talking about when it comes to our values and the rest, and like how we want to live in this world. Maybe Joel, I'll start with you. Just like, what do we need to be training better to engineers and companies so that we can sort of be in this better relationship with our data and how it's being used for these larger systems?
Yeah, I guess I'd say two things. One is that our laws often lag behind the technology that we're deploying. And when you think about the raw material that goes into, say, like a large language model that many of these companies are using to make a lot of money or raise a lot of money, they're often just trained on things that are kind of like in the public commons. And that's kind of the basis for how they're making so much money in some way. I mean, there's a lot of technology that goes into it and algorithms and so on. There's some genuine innovation, of course, but we all created that commons, and the commons is something that we kind of contributed to. And it seems like it'd be great if there was a way that we could also have a stake in it, if we could have a benefit. That's just one point of view. I mean, there's lots of different perspectives on how we should be involved in the benefits from the data that we ourselves generated, that society generated. I guess the second thing when it comes to companies, oftentimes it's incentives. I mean, that's kind of like the big thing that's difficult here, is that the incentives of companies will be different than the incentives of individuals. And so a lot of companies would benefit from having more data about you to get you more engaged with their service or their product. And so, I think that in some sense, we need the laws to catch up or to somehow align those incentives or something, or best practices in companies.
Technology. looking at different domains, healthcare already, treats data very differently than kind of stuff that's publicly on the internet. You think about things like law or education, right? So and education is also particularly interesting, I think, as well as health, because this duality of people wanting privacy, they want, to have safety around their data, they want to know how it's used. So, a lot of people, are very protective of the data. Hard to personalize the experience to you to increase it, hopefully support and outcomes for you if you can't do that either. So there is kind of this sense of, there's always a double-edged balance there. And I think these are the kinds of issues that I think, first of all, again, people need to understand, and we need to try to create policies to make sure that we're creating a future where people are best served by these technologies, not exploited, unintended consequences, try to, mitigate and marginalize risk as much as we can for these kinds of technologies. I think it's really important, as part of this AI literacy, for people to understand, data very much shapes the behavior and how much you can kind of trust the output of the system as being appropriate for you, right? So, when you're training on something as broad as like everything on the internet, it's probably not going to be great for particular cultural elements, right? You're going to see biases. And I think for people to understand where that bias comes from, that it is a very real thing, to know that understanding what data was used actually is really an important thing for them to be able to anticipate the quality of the outputs for them. So I think, that kind of awareness is also very, very important. But I agree. I mean, we really do. I think now we're at a point where we want to both support innovation because we see the great promise, but we really do need to mitigate risks and harms, right? I think we're at a point now where I think people are all, not maybe all, but people are acknowledging like policies and regulations on AI is actually important. And I think that's a great, that's a great kind of thing where we are right now, because I don't think we were there like, 10 years ago, but I think we're very much there now. And now I think there's a lot more detailed work figuring out, well, so what does that mean? And it will probably be different kinds of policies, obviously, for different domains, given the sensitivity of that data, et cetera, et cetera. But data literacy, AI literacy, I think, of the public is, again, still going to be very important, so they can, have a sense of how trustworthy is this thing I'm going to use based on knowing what it was trained on.
There's been a few themes, I'm going to switch the questions, but there's been a few themes that have been popping up, one around trust, one around this automation versus augmentation. But this question, I'm going to paraphrase it. I think it's super interesting, and maybe I'll turn to both So and Tessa to ask about this. But I'll just read it verbatim, and then we can talk about it. Assuming AI becomes part of our life, can you speak to the ways that empathy might be built into the tools that we interact with? Is there a risk that we reteach ourselves an AI version of empathy? So maybe, from two different angles, like, So I'd love your perspective on this, and then Tessa, like, not speaking about the kids, talking about like adults and the sense of self, I'd love to hear from you too. But so maybe I'll start with you. What's the role of empathy as we sort of develop these systems, and how should people then discern what empathy means coming from these systems?
So the question is how we incorporate empathy into the system?
Yeah, that's one of the questions, yeah.
Just by being empathetic. How else? I don't know. Can you code empathy? Or sometimes I think about why don't we train the algorithm, train AI with all the good books, or like sacred books and all the Bible, or just become our AI bias towards Bible and Buddhism and all these great codes of conduct. But that's not how it works. That's not how this AI gets eats the data. It comes from all of us, and we are all, we all have goods and bads. So how do we insert more empathy? By becoming ourselves being more empathetic.
Yeah.
No, it's don't try to change the machine too much. We should focus on changing ourselves too.
I mean, there's an argument made that these systems amplify what humans do. So if we can model it properly, Tessa, I would love to hear your perspective too.
I mean, I was exactly about to say that. I think that one of the things, and I think Cynthia said this right at the beginning, and it's an essential point, is to remember that these models are trained on data that we create, and and therefore they are a representation of us. And if we don't like them, that probably says something. There's a little bit of a mirror effect in that, and so I think being empathetic in how we live our lives is important, in that it will hopefully translate into the data. That said, I think about sort of three things that relate to this. So one is intentionally trying to train these kinds of soft skills or competencies or detection and practice of them into algorithms is really interesting. My colleague Maureen Carroll and I at the Stanford D School have been using NLP to look at students' self-reflections of their classwork and to see if we could identify things like growth mindset or the presence of different design abilities like synthesizing information or being human-centered or navigating ambiguity in student text. And it's definitely taken longer than I thought, but at the same time, it's actually, we're starting to get some really good signal out of that. And so that's really interesting. I think that because one question that I had when going into that project was, well, can we even do something like detect empathy? And yeah, I think you can. I think it's not easy, and I think it's subjective, and I think that a lot more work needs to be done on it than Maureen and my little project. But that was the question that I was hoping to sort of get at, is that even possible? And then
yeah, sorry. Yeah, after you. Yeah.
And then I think the last sort of thing about empathy that I think a lot about that's been mentioned is having empathy for the people and the impact that the designer will have when they're building these types of tools and technologies. And how do we incorporate that into curriculum? So a tool that I use a lot of is that I called impact cascades. And it's a lot like trophic cascades. If you think about an ecosystem, when you take away a predator or introduce a predator, there are all of these sort of flow-on series of consequences. And Yellowstone National Park here in the US with the wolf is a famous sort of story of that. Well, I like to do that with teams as well that are designing things. What's the impact of what you're having? What are the unintended consequences? What are the unintended consequences of those unintended consequences? What could be the unintended consequences of those unintended consequences? And then we start turning design not into a question of can we, but should we? Or if we do it, we're doing it with our eyes open, knowing that, seeing things that you like and only seeing things that you like could lead you into a political echo chamber, knowing that they could be potential consequences, and then putting in measures to balance them and those sorts of impacts on society. So I think there's both empathy like in the machine, so to speak, but then there's also, the empathy in the design process.
I really like that can we or should we. Sorry, so you want to jump in?
Yes, I just remembered a research paper I read back in 2014 or 15, study on empathy. And the conclusion is that the more you're aware of your own body, the more empathetic you become. So one way to increase empathy is to spend more time with your body, not with just machines or screens. Stay away from the screen.
I need to personally keep that in mind. Maybe the last question is the really big one, as we only have a few minutes left from the audience, is effectively, what should regular people do? Like, what are the opportunities for everyday people to be part of these conversations? How should everyday people think about their agency, not just for how they use it, but also then how they should be interacting with the world and hopefully get it to change in the way they want it to. Maybe I'll start with Joel and go to Cynthia.
Yeah, I mean, the caveat that I'm, not an extreme expert in this, but I guess the kinds of things that come to mind are, one, to be politically active, like that, to make this a political issue. If it's something that we're afraid of is going to impact us, to make that, to elevate it. And I think the second thing, which other people have highlighted here in the panel, is, to, if possible, to really lean into this kind of critical literacy and critical thinking around the technology. There's going to be so many messages that are being bombarded us by media about this technology is going to kill us, this technology is just a nothing burger, and the reality is probably someplace in between. And it's really hard to navigate. So I feel like, I feel a sense of compassion. Like, it's a weird technology, it's coming down the pipe, we don't know exactly where it's going, there's all this uncertainty about it and how it's going to impact our lives, and maybe just some compassion for yourself. Like, we don't know where this is going. And maybe just we've always, as humans, lived with some uncertainty, and so maybe this is another wave of the human condition, unfortunately.
Cynthia, I'd love to know what you think about this as well.
Yeah, so I actually feel like I could have said a lot on the other question. This one, I feel like
I mean, you could answer that one first if you want.
I mean, I think, for this question, I mean, I would just echo what Joel said. I just be engaged, be a citizen about this. I think, unfortunately, the burden is still on us as individuals to figure out where the credible sources are. Even, I will read articles produced by, top quality venues, and I'm like, that is not correct. So you just got to be aware that it's hard to know where the real ground truth is with these technologies, other than it is rapidly changing. And so I think the active voice as a citizen, I think, is just continuing to wanting to make sure that this is being used in a way that's equitable, that's beneficial, and just holding leaders' feet to the fire to make sure that happens. And so part of that is to become just more aware of the technology. But I mean, the sad thing is it is really a burden on citizens to do that right now. And hopefully by having more high quality educational materials by credible sources and so forth, like in our K-12 things we talked about, we can have a better control of making sure that people are being informed in a reasonable and responsible way versus a hype cycle, controversy for click kind of way, which is unfortunately the world we live in right now.
I mean, I'm aware it's a very American-centric view, but I feel like that's the only way to get into some form of checks and balances of just like we need to bolster what citizens know in order to push back against the capitalistic system, governmental systems, etc. You're right, Cynthia, I should have asked you about the empathy question as well, so maybe you can close us with that one. Oh, you might be muted.
I'll just add two quick things. So I think what has already contributed was fantastic. I'll just add two quick things. So one of the things that we've discovered, so we build these social agents, these personified AIs that engage with people of all ages as I call them helpful sidekicks. So in an educational context, what we have found is when we design our robots, and I will say when we talk about AI systems, it's not just machine learning. There's lots of tools you can use to create an experience, right? So we can have, kind of very well-informed pedagogical practices and so forth that might leverage some aspects of machine learning, but we can control the experience more than kind of what a machine learning model will do. But I will say what we've discovered is when an agent interacting with, say, a child who's trying to learn something, the child often, and you got to design it this way, but can view the AI as kind of a non-judgmental, empathetic other who is really there to support their learning process where they don't feel like they're being judged. And in something, anytime you feel vulnerable, like learning something you don't understand, we've seen a real benefit of that. We have found that the more expressive and empathetic our agents are, the more engaged people are. We are emotional beings, so thinking about the design, the emotive design of these experiences can be done in a way to enhance and engage people so that people are actually more successful with the technology than they would be if you didn't address it at all. We have also found that we are social creatures, so the behavior and how these agents show up to people we learn all kinds of things from each other, right? There's knowledge and skills, but there's also attitudes and perspectives. So we have discovered if you design an agent to be pro-social, to be empathetic, to be curious, in a game or an activity you do with, say, a child, lo and behold, guess what? The child starts to exhibit more of those behaviors as well. So there are ways to think about the design and how these agents show up in our lives that promote and enhance these human qualities that we want to see more in ourselves. So that's one insight I'd like to share. The other one is we've just started or finishing up a project specifically looking at social connection and empathy, where the AI is more of a mediator connecting someone and say stories that they tell about their experience to other human stories. And so that involves being able to do a sentiment analysis on relevance and connection between these stories. But we have found that when an agent serves this role of helping to connect people in a more emotionally resonant, engaging way, they feel more optimistic about humanity, they feel more empathetic. So again, instead of thinking about kind of what we hear a lot about, social media today is, causing a lot of mental health issues and so forth, there are ways to try to help enhance human connection through these AI technology as well. So it's all up to us on how we want to design these technologies, right? And that's my parting comment. It is up to us. What are the values? What are the aspirations that we want with this technology? And we have to build for that. And we can.
That's such a wonderful way to end this conversation. This has been such a fun hour. I hope to meet you all one day and actually show you around TUMO here in Yerevan, but thank you for joining us virtually from around the world. This has been a great conversation, so thank you again.
Visit tumo.org.
Yeah.
TUMO is a free of charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend TUMO centers each week after school. TUMO offers 14 learning targets at the intersection of technology and design. TUMO's educational software, the TUMO Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. TUMO makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Tumo is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend Tumo centers each week after school. Tumo offers 14 learning targets at the intersection of technology and design. Tumo's educational software, the Tumo Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. Tumo makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by Tumo's workshop leaders. Project labs with international professionals. At Tumo, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several Tumo centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org.
Where my research focuses on machine learning, and in particular, I think a lot about machine learning for human learning. So when I first started, I was a PhD student at MIT, and I'd been doing a lot of work on robotics and what's known as decision-making under uncertainty. And it's this field of study that's been around since the 1950s to think about how we can optimize and sort of systematically consider how any intelligent agent might learn to make decisions under uncertainty to try to optimize some objective. And I thought this whole area was absolutely fascinating, but I wanted to do something that I felt was more directly connected to some of the application areas I cared a lot about. And so when I started thinking about education, I thought, well, that really does involve, many interactions over time with teachers and parents and peers, and textbooks and videos, and of course, lots of problems and activities, and that in order to try to sort of learn things over time, and then also, of course, to accomplish the skills one needs to make one's goals. And so when I started being a professor, I really started delving into this with a lot of wonderful students of thinking of how can we use ideas from things like decision-making under uncertainty and reinforcement learning to try to impact education. And when we did this, we had some successes. Together with some wonderful colleagues, we did things like create systems which would help students learn basic Korean sort of vocabulary 1.3 times faster than the previous system, or to create things like games to teach kids fractions that help them to persist for longer through using reinforcement learning to try to adapt the levels and the activities that were given to students. And we also worked on design so that it would allow students to learn more by making sort of joyful interfaces and using adaptive algorithms to try to make the experience both more exciting and ultimately more effective. And so this was work that we've done for, a number of years. I've been working in AI in education about for 10 years now. But of course, then the pandemic happened. And when the pandemic happened, 1.6 billion children left school. And this has had enormous negative implications on children in the US and throughout the globe. And we're starting to see the results of that. And in terms of some of the downstream learning outcomes. And so headlines like the pandemic erased 2 decades of progress in math and reading in America, or that now in America, 38% of 8th graders are below basic levels of math performance, really struck home for me during the pandemic. And I'm the mother of 2 young boys. I was living this day to day of sort of watching, how much we lack sort of support and sometimes to really help students when the education system is in a crisis, whether due to COVID-19 or due to other systematic factors. And so during this time, I really started changing the way that I was thinking about how machine learning and AI might support education. And in particular, rather than thinking of sort of how do we have a computer just mimic sort of what might be like in a one-on-one, human tutoring experience, which is one really powerful form of education, I started thinking much more about the complete learning ecosystem, which can consist of teachers and guardians and peers and computers, potentially, and educational software and students. And started to think about how might we use AI to really support the whole ecosystem so that we can really hopefully enable really powerful changes in education. So what I'm going to do today, I know we only have a short amount of time, is to talk just briefly about a couple different projects we've been doing in this space to give an illustration of where I think AI could be really powerful. And I think that with the new large language models and generative AI, there's a ton more potential than there's been in a long time in order to further enable this sort of transformation of the learning ecosystem. So the first thing I'm going to talk about briefly is thinking about how we can make robust artificial intelligence to support true learning progress for everybody that's involved, so for all students. And I'll give an example of a narrative-based educational game. So this is a collaboration with James Landay, who's a professor in human-computer interaction, and some wonderful students, Sherry Rowan and Alan Nee. And the idea in this case is to think about creating sort of delightful educational engagement for students that could be used both inside the classroom or at home. And in this case, the student goes on an adventure to try to help sort of support the planet in this artificial world. And they're guided by a monster, an avatar that they get to pick, who's going to help them as they go on some different quests. So in this case, they're trying to transport chocolate across a river, and they need to figure out sort of whether how much weight this will incur for the boat. And one of the things that we did in this case is that, like in many educational interfaces, sometimes students get stuck. And so we wanted to be able to have some simple interaction with the monster or avatar to support the student as they went through this. And one of the key questions is that while there's been amazing work in educational research, often it ends up with pretty broad guidelines. And those guidelines might be things like, should you do all practice for one topic in a row, or should you space it out and interleave with other topics? So it can have some really beautiful insights, but when we think about what that might mean for a particular educational software product, often those guidances don't go down to the granularity that we might need. And I think that's where machine learning can come in. So in particular, in this case, what we did is we had sort of a live reinforcement learning algorithm. And some of you guys might be familiar with reinforcement learning, many might not be. It is something that now powers some of the incredible advances we've seen for ChatGPT. So it was used to go beyond just mimicking how people use language in the past. And for ChatGPT, reinforcement learning was used to get much, much better responses for the chatbot. Similarly, in this case, what we're using it for, these algorithms, is to think about as we're watching, as these systems are interacting with the students, and we can observe how well they do on a post-test, how can we figure out what interactions with the monster avatar were responsible for helping the student more or less effectively in that educational task? And as we get data, we close the loop, and the monster avatar changes how it interacts with the next student. So this is a sequential study where as students work with the software should get better and better at assisting them to really have kind of a continual improvement automated system. So in this case, what we did is we did a live study with around 200 students. This was during the pandemic. Sherry and Alan, the students leading this, were phenomenal. And the system actually changed how it taught students during this time. And then in addition, one of the big questions is that sometimes, not all scenarios are suitable for being able to do this kind of live machine learning, where we can assume we get the data in real time and then actually can change how the system is working in real time. I have done some collaborations with War Child, which does amazing work in a lot of conflict regions. And in some of those areas, they give say an iPad or give some tablets for a month or two and then come collect them. And so you can't do necessarily this sort of real-time machine learning. In this case, we could, but we wanted to think about, could we learn sort of a way to teach students that we thought would also transfer to new students that might use this? And this generally also has been another big challenge in artificial intelligence, is thinking about, if we train on one data set, will it work well when we deploy it in a new situation? So we wanted to look at that in this case. And one of the things that we found that was really exciting about this is that our AI system most benefited the initially low performing students. So we compared our system to also having a control group where we didn't have this kind of monster adaptive assistant who was able to help the students. And what we found in this case is that the control group
of our panel is working in the future. How AI is changing what skill matter and tomorrow's jobs. It's an essential topic because, hey, it's not easy to prepare for jobs which don't exist. I'm Stephanie Griffiths, Field Chief Data Officer at DataIQ and expert in change management. I am not a tech guru. I came to data and to AI because it is key if I want to work with chief financial officers, investors, or chief technological officer. My background is actually political sciences. And having 3 teens and being a visitor lecturer at various universities, I am totally fascinated by the new challenges facing education. Today, I'm joined by a global cross-disciplinary panel, and we are very lucky to have, first of all, Marilee Nika. She's an AI product lead at Meta, and she's also leading AI product bootcamp. It's a key area that you need to understand, because if you don't understand how AI products are made, how are you going to understand what the future of work is? We also have Bill Swartot, Director of Technology at the Institute for Creative Technologies, and is leading amazing AI research projects. We also have Jacob Klein. He's a NetTech founder. He founded Motion Math, and is also a NetTech product consultant. And by the way, he wrote the best summary I ever read about how AI is impacting the classroom. And finally, we got Indy Johar. He's an executive director at Dark Matter Lab, who's aiming at solving key challenges for societies. His background is actually architecture. So I'm not the only weird one here, not coming from data and AI. I'm going to take 2 minutes to frame the topic, and then we'll start the conversation with our panelists. So, today, you could be a prompt engineer, an AI evangelist, a chief AI officer, an ethical AI manager. Today, you can work in logistics and calculate the best routes to optimize the transport, saving on carbon footprint. You could manage a production unit and anticipate which machines are going to break down first, so you get all the material to repair them, so you don't stop the production line. Today, you can be a teacher and improve your lesson plan thanks to ChatGPT. Today, you can be a student using Grammarly to write better. Today, you can be at school in Yerevan, and you can go to TUMO after-school digital courses. That's a positive view of the future of work, and those jobs are just completely new. And then there is another aspect. Today you can also be in Kenya, paid a small amount to clean ChatGPT from offensive images. Today you can be in a PR agency and maybe losing some client because your client is now using ChatGPT to write some PR release, some press release. Today, you can be in a training business, and suddenly you're losing some work because your client is using Synthesia, which is a text-to-video tool, and suddenly you can generate a video in multiple languages. Today, you can be a student avoiding to write your paper thanks to ChatGPT. Today, you can be at school in Bordeaux, France, and think technology is the most boring topic from the French curriculum. A pretty negative view of what's happening at the moment. And we have those 2 sides. So, I'm going to kick off with my first question for our panelists. For you, and starting with Marilee, what do you think a positive future of work could be or should be?
Thank you. This is a very good question. And hi, everyone. It's an honor to be here talking to you. So as mentioned, my day job is I work in AI at Google and at Meta. But on my side job, I have founded the AI Product Academy, and I teach people how to prepare for this amazing future and how to build AI products. So something that I have found in my day-to-day job is that with AI, I do more for less. So what does this mean? So with AI, I have automated repetitive tasks. If there are a lot of data around, I just literally create a little script or use ChatGPT and all these tools, and everything that would take me hours happens in seconds. Okay. So this boosts productivity for me across every single thing I do on a day-to-day job, whether is writing an email, whether it's designing the requirements for a new product I want to create, or whether I need to make decisions for myself, my company, my team. Number two, as a product manager, we come up with creative ideas for new features we want to create for our users. So with these tools, I am as creative as ever. So I always come up with innovative solutions and solutions that are targeted to specific user groups. So I would spend thousands of dollars in the past going to agencies and said, hey, can you do market research and tell me what users would want, what user personas would want something that does X, Y, Z. Whereas now I'm just literally going to Bard or ChatGPT and say, hey, come up with personas for me for a speech recognition product. And it will say, okay, these people, these people, these people. Number three, I develop personalized experiences. So as product managers, we want to create experiences for people that are unique, that will go viral, that will find a great product market fit. But with AI, I'm able to create personalized experiences, and that is something that you need a lot of data in order to process and understand what people really want to do. Last but not least, at work, I'm a senior at work, so I've worked for like 10 years plus. It's kind of tough to upskill at this point, but with AI, I have personalized upskilling, so I know what I'm missing. I know what I need to get out there and read in order to stay ahead of the curve as well. So ChatGPT is incredible. AI is incredible all the way around. That's the first answer. And again, thank you for having me here. I'm excited.
Okay, so let me rephrase to see if I understood well and for the audience. The positive future of work, your vision, would be boosting productivity, more creativity, personalization at scale, and knowing yourself better. So, did I capture that well? Okay. Right. Jacob. Yep. Jacob, would you have anything to add to what would be a positive future of work for you?
Yeah, I think Marilee sketched it out extremely well, some of the ways that it's already impacting my work. I mean, what's exciting about it for me is a future of abundance, where we have more time. Hopefully it's shared more widely with less tedium in work, and a faster iteration time between I have an idea, let's get input on it, let's get AI feedback on it, let's get a sketch of it much more quickly. User personas is a huge one. Another one is QA testing, having AI agents that can run through every possible variation of a product to find possible bugs. Let's execute it more quickly, let's get it into users' hands, and then let's analyze the data more quickly. So quicker iteration cycles of building and improving products, more creativity, and yeah, more abundance. It's potentially part of an exciting future.
Okay, so the future of work for you is actually promising because you will have more time to focus on more interesting and difficult, I guess, activities.
Yeah, start more businesses, do more projects, collaborate with more people.
Okay, do more. Okay. Bill, what do you feel?
So I think Jacob and Marley have really summarized it very well. I have just a few things to add. One is, and this is kind of implicit in some of the things they were saying, is that I think AI has the potential to remove a lot of the drudgery from work. Basically because often, ironically, the drudgery aspects are sometimes the easiest to automate. So those are kind of the low-hanging fruit. Those are the things people will start doing. And the benefit of that is it frees us up to do the more interesting parts of the job. So, you know, if you've got an AI education system and it is drilling the students on things that they need to know, the teacher can concentrate on helping students who are struggling, who are having problems, which is really where a personal touch can make a real difference, as an example. The other thing I think that AI is going to do is serve as what I would call an experience accelerator. And what I mean by that is systems have been built that, for example, use generative AI to support customer service workers. These are the people who, you know, respond to the texts that you do in a chat where you say, you know, my washing machine is broken and the red light is on, and why the heck can't you guys build a decent machine? So these are not fun jobs, actually, because, and the turnover rate is pretty high. It's about, people typically last about a year in those jobs because people are always yelling at you. And what some companies have done is started taking the advice interactions from their most senior customer service representatives, incorporating that, fine-tuning a generative AI system so that, and then making that expertise available to the more junior people. The effect has been, first, that the quality of the advice on average that goes out has gone up. And secondly, that the turnover rate has gone down. So this is an example of a win-win. And the reason that it's working is because you're giving the more junior people the experience of the more senior people, making them act essentially more like more senior people without having to spend as much time on the job as would be required to actually acquire all that experience yourself. So it's a real experience accelerator in that sense.
Okay.
The other thing I think that this can do is make it more easy for people to get access to expertise. You know, if I'm working on a project and I need somebody who's an expert in some particular area, let's say an expert designer, you know, I can use AI to help me find either people, or with generative AI, I may be able to get a first stab at a design of a graphic art that I might need, for example. The third thing that I actually am really excited about, and this ties in with a project that we're doing at here at USC, which is to start up a new center for AI in education. It's called the AI Research Center of Excellence for Education. And the idea behind it is to both build tools that use AI to deliver educational content, but then the content area that we're focusing on is AI, because we see a real need across, you know, at USC, across the university, for building up AI literacy. So not necessarily teaching people how to program an AI system, but to develop an appreciation of what AI is, what it can do, and what it can't do, so that you know when you can use it, when you can trust it, and have a better idea of that. And that's true, you know, across here in the United States, I would say, across society at large. And so we're going to be really looking at how can we upskill the workforce. Well, the thing that's exciting about this is, I think, technology, as it moves forward, and it's moving forward rapidly, is going to mean that people are going to have to learn throughout their lives. We're going to have to be lifelong learners. And that's a real exciting thing, because it means you're not as likely to get stuck for 20 years doing the same job over and over again. Technology is essentially going to serve as a forcing function that will force us to continue to grow throughout our lives.
Thanks,
and that,
Bill. Yeah. I would like to, because you said a lot of interesting things. So to recap for you, the future of work will be more human, actually, because more personal and personalized. The future of work will be delivering a better customer experience. It will be more delightful. The future of work will be less risky because you will have access to experts. And the future of work will be actually more challenging because you will have to learn constantly. And you know what? Some people might be very happy with that, but some people might feel actually it's quite difficult to keep on learning and reinventing themselves. So for some, it might be positive. For some other, I'm not sure. So it's an interesting, interesting thought. And I just wanted to point something to bounce back on improve customer experience. It made me think about IKEA. IKEA had a lot of people working in customer services. Now they're using, and they relaunched, a great AI chatbot. And the people who don't need to work in customer service, and it was frankly a bit boring, they did upskill them to become designers. And they are really putting emphasis on new services to help you, for instance, to build your kitchen. So great upskilling opportunity. Finally, Indy, do you mind sharing with us what is your vision for the future of work?
Yeah, delighted to be here. Amazing panelists. I suppose my concrete way of looking at this is that, in a way, and just to sort of play a little bit, a PR press release written by ChatGPT is worthless. No one will read it on the other side. So I think we have to start to think about, when we commodify this stuff, what actually is the other side of this. The only thing that a PR press release written by ChatGPT will be read by will be another machine agent. So it's a machine-to-machine dialogue, not a machine-to-human dialogue. So that's one thing we have to really start to understand. Second, I think we have to understand that this is basically the removal of the middle classes, the removal of the administration landscapes, the removal of bureaucracy is what we're talking about. So we're going to see the bifurcation of our economies into what I would call the revenge of the real, the revenge of the material, and the revenge of the highly embodied knowledge. We have to talk more and more. The human landscape will be about multidimensional embodied knowledge. So the human economy, because I would argue that we're living in a kind of humans behaving as bad robots. And as the robots get smart enough and our machine capabilities get smart enough, we can unleash embodied intelligence, which is multidimensional embodied intelligence, to be a key factor. And this is where machine capabilities become very powerful. But it's the embodied intelligence which will become the key value added. So if you're going to write, there's no point writing a blog from ChatGPT. There just isn't a point. This is the waste of informational landscape. So actually what you have to be is more James Joyce. And to be more James Joyce, you're going to have to be quite extraordinary. So what we're seeing is the removal of the average, the removal of the mundane from the system, and we're going to have to actually drive the massive extraordinary. Who writes James Joyce? We're going to have to live in a world of James Joyces to be able to actually imagine the new embodied creativity landscapes. So I think there's a massive transformation coming in terms of what does it mean to be human. And I think we're massively underestimating the parallel story. Everyone talks about the opportunities offered by AI, definitely. But what we need to be thinking about is reimagining what it means to be human in 21st centuries. And I think that is a much bigger revolution. It's a revolution equivalent to 1650, when the UK invested in educational reforms before the Industrial Revolution. And we think it's a little bit faster humans. It's not a little bit faster humans. It's a completely different way of being human. And it's already visible. If you're really brilliant these days, you operate at the intersection of craft and emotional intelligence. Craft is the ability to be both strategic and didactic with embodied intelligence. And your emotional intelligence becomes a key function to be able to bring these capabilities together. So we're seeing a fundamental shift of what it means to be human, and that will be machine-assisted, no doubt about it. Machine-assisted craft capability is going to be extraordinary, but we're going to see this bifurcation of our human economy into this kind of more than human landscape and the revenge of the real. And I think it's really worth recognizing the revenge of the real. Our material economy, our energy economy, is all about to be transformed, and that's going to be massively machine-assisted in that future. That's it.
So, I mean, you're bringing something super interesting. So now I'm going to start with you with the following question. To be more human, which skills and which courses would you launch tomorrow if you were working in a university?
So, okay, I'll I think we're living in the equivalence of Leonardo da Vinci's Vitruvian Man moment. Leonardo da Vinci reimagined what it meant to be human, right? He put the human in the middle of the circle and the square because he was reconceptualizing our relationship with the world. We're moving from an idea of humans as individual isolated intelligences to interbecomings. Not interbeings, but interbecomings. It's an idea of actually being an emergent reality.
Sorry, can you define a little bit more what you mean by interbecoming?
So intelligence is not something I possess in my head. It's a function of our relationships, right? It's an embodiment. It's an interbeing. It's a function of this discourse. We often think of intelligence as a capability rather than a relational asset. And when you start to see it through that lens, you start to reimagine. We already know microbiomes, your microbiomes affect your cognitive capabilities. We already know epigenetics affect how you think. We know microviolence, if you have a car rage in the middle of it, will affect your capabilities to make decisions for 6 to 8 hours. So I think we're going to have to unlock a really deep reimagination of being human. And that I would also say is we're going to see the expansion of our theory of communicable intelligence in the planet. You're already seeing extraordinary progress going around about communicating with whales and other things. We're going to massively transform our capacity for interbeings with human and non-human systems.
Okay, but you didn't answer my question. I'm going to tease you here. I understand where you're coming from, but really for our participants, if you had the opportunity to be a guest lecturer at a university, which course would you suggest, which is missing now, to help us to rethink to be more human?
I would almost certainly put a course at the intersection of art, philosophy, and radical technologies. Because I think at the intersection of those things, I think a new world will be born. So I would not put together a capabilities class. I'd put together how you think and see the world, how you craft into the world, and the technological capacities. I think we are underestimating that is where the revolution will be born, in those intersections. And it's not going to be born in the Capital Venture Studios, it's going to be born here.
I love that. So let me tell you a personal story for 1 second. I've got a daughter, she's 15, and she wanted to do a program, maths and art. And in France, she was told, you must be kidding. You want to be an engineer and you want to study art? No, do maths and physics, but don't do art. And she couldn't find a program at school.
But that is genius. That is where it's the intersection of logics. It's at the intersection of different logics we're going to see new forms of intelligences emerge. And that is going to be a key role of what it means to be human. And it's not just going to be art, it's going to be all of these things in different formats. Sorry, I've spoken too long. Thank you.
Gil, seems you are actually within academia. So I know you've been thinking about those questions. Which type of courses and new skills do you want to teach your students?
Well, I think at the university, really, we need to have as really part of the core curriculum, that is the things that everybody takes, is an understanding of what AI is, what it isn't, what it can do, what it can't do, and really kind of tying in with what Indy was saying, a course that is not really about, programming in Python. We know how to do that. But a course that is talking about how AI relates to everything else. And I think there is real value at looking at interdisciplinary studies. And the center that the Institute for Creative Technologies is really, in its name, is about bringing together creative people who know how to create stories and characters that people find engaging, to work with people who understand advanced technology to create experiences that people haven't been able to have in the past. So it's that kind. I feel that there is that real need for and trend toward interdisciplinary approaches, and I think having people aware of what AI is really, not just what you read about in the press, is really important going forward.
Okay.
What I say is Most people know how to spell AI, but not much else.
So,
I would
Jacob,
agree.
yeah,
Yeah,
Jacob,
I would-
you actually created an edtech. So, do you still, we think, need to go to university, or edtech can actually replace it and give us the knowledge we are missing at the moment?
Well, in the United States, college has been a little overhyped in the last 2 decades. So there are a lot of students that can, I think, productively go straight from high school to a career or a trade school. But certainly the university is a great invention. It's been around for over 1,000 years. It's not going anywhere. We should certainly think about introducing AI in most, maybe all areas to think how we can productively use these tools going forward. But I think to what Indy said earlier, the cost of writing is approaching zero, creating just content that fills the page and has some semblance to the topic. So it really fundamentally calls into question what is the purpose of writing as a vehicle for thinking. So if I was starting a university course, I would mirror it after there's a professor at Penn, Justin McDaniel, who has a monk-like deep reading course where students have to put away all technology, sit and read a book for 3 hours straight, and then discuss it for an hour. And I think those kind of purely human deep thinking skills are not going away, and there's a real risk in becoming too dependent on tools for thinking. So I would marry the two. Get used to the tool and also think for yourself. And think in your writing of how to express things with brevity and authenticity, because those are things that will be even more valuable when huge reams of AI-generated content is available at the click of a button.
But how can you push people to be more authentic? I mean, which courses can you think about to do that?
Art is a good one. I mean, I think it can be true in any subject, really. What are you really thinking about values? What do you really value? What do you want to bring into the world? What is authentic to you? What's not just going to get a good grade in this course, but what is going to express some of your deep beliefs and values? That's something we often don't ask in writing or in project-based learning.
Yeah. That's a very interesting one. So I work with clients from very different industries, and sometimes they come and they're like, okay, we want to use machine learning, and I step back and I ask them, okay, let's not talk about the tools. Can you tell me which value you want to create? And they're like, well, I want to be efficient. I want to save money. Okay, you want to be efficient. You want to save money. To do what? And that's where the interesting chats start. Because if you want to be more efficient to do the same stuff, maybe it's not worth it. Can you be a bit more creative? And on that note, not sure you know Decathlon. Decathlon is a retailer in Europe, and they do sport garments. And they moved to selling garments to also renting garments. Why? Because they rethought the value they wanted to create. The value now is reducing carbon footprint. So the KPI are reducing CO2. To reduce CO2, they need to produce less garment. So they need to extend the life of the garment. And by rethinking the value they want to create, they are rethinking the business model, and therefore they are rethinking the skills they need within the company. But I don't want to speak too much, because Marily, I would love for you to also deep in that question and share your perspective.
Thank you. Actually, I come from the other side of things, where I did create a course, and I do teach at a university, and I do teach a course for anyone that's interested. And this course is called AI Product Management 101. And it's for people that want to understand how to leverage these technologies into their day-to-day at work. So for example, it's great to be able to type in text and get an image, but okay, what can we do with this? An amazing example is what Adobe did. So Adobe, I'm sure you all know the company. So they have the technology where you can type in, hey, like a cat holding a mirror in the plane or whatever. You get the image, great. But what they did is they said, hey, our user base is designers. So we will create a tool where designers can type in text and get an image. But what they will do is they'll have a client, and the client can say, for example, hey, I want an invite for my kid's birthday party that has a turtle as a theme. So they can create the template that's very custom made. And then the designer can actually tweak it and then give it to the client. So this is an incredible thing because it saves so much time from the designer. It makes the client feel super special because they're going to have such a unique, perfectly custom AI-focused invitation. They make money for it, so they can take more work. And with this money, they can keep paying the subscription from Adobe. So it's like this beautiful new ecosystem that gets created. So yeah, I created this course, and actually I've had so many students up to date. If there's anyone interested, I'm happy to provide discounts for anyone in this group. You can find me at merrily.substack.com. Please reach out. I created what I wish existed right now. Yeah, and I've loved every second of it to the point that I'm like, should I leave my day job to do this? So yeah, that's the answer.
So it's very interesting because nowadays we have universities and they will always be there, and I love university. But there are also a lot of new players in the educator ecosystem because universities are not enough to upskill us for those jobs which don't exist. Do you see more partnership between universities and the private sector, or do you think actually the private sector is going to take over and there's more and more content? So, two questions here. I mean, how do you see universities evolving? And second question is, I'm always amazed by the great content there is, but which content can I really trust? And for me, curation is really the word of the future. How can I find my way? So maybe if we can start with Jakob on this one.
Well, I think teaching practice is certainly going to have to evolve at all levels, but probably more fundamentally as we get into upper education and professional development, as students are closer to using tools in their profession. I would be wary of teaching students in early elementary to get too deeply into these tools because they're going to evolve so much before these students reach the workplace. So I think what Bill said earlier, it is going to be much more continuous learning. I think there's great opportunities for universities to do a lifelong learning, to have adult learning, and have that intersect in some ways with undergraduate or graduate studies. And smart companies are going to be investing in their learners to keep them longer at their firms, continuing to grow and have more varied career paths, because some jobs are going to be automated, but almost all of them are going to have to be augmented to perform at a high level with these tools. So it is going to be continuous education. I think adult learners, workers are going to find that either outside, but ideally in concert with management at firms.
Indy, how do you think we can find our way between all those fantastic content which are emerging? We have thousands of courses, you have Coursera, you have YouTube. How can we find our path?
So I think there's a kind of fundamental question right now, which I think is worth thinking about if we talk about this future, the data. So I think Google and Facebook and Meta publish more AI papers than Stanford, right? So so why that's important is the big fundamental question is what is going to be the data economy of the 21st century, and how do you build a new data economy which allows for generative capabilities and decentralized generative capabilities of society. So if you look at what happened in the UK with open banking, I think we're going to have to start to create new forms of data institutions that create the liquidity of data, and then we're going to need new types of educational institutions which aren't going to be, they're going to be more akin to polytechnics and vocational hybrid learning environments, advanced vocational environments, which are working with real-time data and real-time capabilities in new formats. So I think we're going to see a shift from what I'd call academic institutions to vocational institutions or advanced vocational institutions. By vocational institutions, I imagine an Oxford thinking through a vocational lens, not like plumbers, and I'm thinking about a fundamentally different pathway of how we learn in craft. I think those sort of things are going to be really critical as part of new institutional landscapes. So I think we're going. Second part, it's also very clear that most of the data infrastructure that we're all part of, all small organizations, large organizations, what we're seeing is new data economies emerge, and they're going to become more entangled. So I think universities can play a very powerful role in building back-end learning infrastructures for a whole front end of micro-organizations. I think this is a really powerful moment for actually starting to reinvent universities in a much more radical way for a data-rich economy, and starting to create ecosystems, informational ecosystems, which are buried together and working together. It's almost like guilds, 21st century guilds of knowledge, which are working at the kind of front end of learning and practice, but also have the academic reflective capabilities at the background. So I think we're going to see a very interesting blurring of the kind of public-private divisionality, the university academic versus practice divisionality. These are all going to get blurred. And I think whoever can create these sort of institutions is going to get a massive leap forward in the kind of cognitive learning capacity of society as a whole. The asset of society will be the learning capacity of societies. That is going to be a real fundamental asset. And that's not about individuals. It's about societal capability in fundamentally different formats. So I think that we're in the middle of a revolution in terms of what does that learning infrastructure look like. And forgive me, I don't think it's about, I think Coursera and everything else was 2001. I think this is much more of a structural revolution in our learning capacity of that future.
So do you mean that universities need to teach us how to be open to reinvent ourselves constantly, and to be okay with that constant change, but the specific micro learning will be actually delivered very often by companies because they will have lots of data about what is needed? Is that where you're going to?
Yeah, so there's three layers. One, I think we'll look at sort of like open data, like open banking, which will create the data infrastructure. Two, you'll create vocational learning capabilities, which will look at the capabilities lens. Third, what you'll look at is ecosystems. Startups will be part of the knowledge ecosystem of a university. They won't sit separately. They'll be in shared reflective learning environments. I think that is going to be a key part of building what I would say is a compounding learning economy. Economies that can compound their learning at speed and scale is going to be really, really powerful. So I don't think the future of a CEO of an organization is not CEO, it's chief learning officer. I think learning becomes a fundamental coherence mechanism in society, as opposed to command and control. Command and control is an industrial worldview, doesn't work in complexity, doesn't work in actually any form of the entangled realities we're living in. So I'm just being nuanced about the kind of scale of this. This goes all the way from data infrastructure to new capabilities to new ecosystems, which are genuinely functional learning ecosystems that bridge the gap between university and private sector in radical different formats.
I love the chief learning officer, and to that point, Airbus just relaunched the training. Well, they switched from training program to actually creating a training company, because they have so much learning. They have people that they need to retrain constantly. It's actually now becoming a business for them. It's not something just internal. They are going to make money out of that. And the chief learning officer is a new CEO. Love that. Marilee, what do you think about that?
I honestly agree with everything I heard so far. No, but this is a very interesting discussion, and I'm happy the dialogue is open. We're discussing this whole thing. One trend that I have noticed is that universities now have, as part of their programs, kind of a placement. So it's interesting. You get kind of more the research skills, but you also get to apply them in some institutions. So that's a great bridge between academia and companies. The other thing I noticed is that at companies, you see departments that were purely research to have an area called applied research. So this is when the people say, we produce all these papers and all these things about AI, but what we do here is we take this amazing research and we actually apply it and integrate it to the ecosystem of the company. And to me, if I could go back 15 years ago and tell myself what to do, I would say, find that niche, how you can productionize, how you can apply, how you can integrate top of the tech research, into application like that. So it's the applied skills that I want everyone to learn. It's great if we can read and learn about Python, great, but like how does it translate to needs that you roll up your sleeves and you actually create? So that application is what I wanted to call out.
Bill, Jacob, do you want to add something?
Well, I'll add a little bit if I could. I think, at USC, so I agree totally with everything that Indy said, and Marley. What we're doing is really investigating how the university can support diverse pathways to getting an education. By that we mean it's not just about getting a 4-year traditional degree, but there are lots of different ways that you can do that, and lots of different experiences that you can have along the way. So we are looking at creating things like, to Marley's point about providing people with experience on how research can actually be used, something we're calling Semester in Tech, which would be a chance to be embedded in a applied research lab, either somewhere at USC or in industry, and learn how things are done, how applications are built, how things move out, and begin to learn that. We're also starting to team with some of the local community colleges and looking at providing other degrees other than such as certificates, rather than standard 4-year degrees that show that you have expertise in some particular area. And I think as we see this idea of continuous lifelong learning really take hold, that is going to be much more the norm going forward.
Jacob, do you have anything to add?
I love all these integrations. I would just also advocate for the university as an oasis from productivity as well, as a place to also think about what it means to be human, what it means to be a citizen, and also to pursue research just out of curiosity with no sense of whatsoever for how it might be applied, if at all, in the future.
Actually,
Absolutely.
The oasis for research, that's what I encourage people, our clients to do. Data scientists are also data artists, and they need to have time to explore the data just to understand deeper what they mean. And if they are continuously harassed by business, you need to forecast sales. They do take that into account, but they can't actually sit down and look at all the data points. They don't have time to do that. Then they can't come up with ideas. And there was, of course, a famous 80-20% of working time at Google. I think because we can become productive, we should now be able to spend more time on research and applied research and thinking, definitely.
Mm-hmm.
We are starting to have questions from the audience. So one of the questions, a very interesting one, which specific industries do you think will be most impacted by AI? Customer service was mentioned. What would be your top 3? Anyone wants to take this one? Well, I could start on this one. So we work with anything from retailer to pharmaceutics to manufacturing, and we are realizing that AI has an impact in every single industry. To give you a very concrete example, anticipated maintenance in manufacturing existed before, but now it can be scaled. In product innovation, you can grasp ideas from customer testimonials and feed that into R&D, so it's impacting retail. So to rephrase the question, for me, it's which companies are acting quicker and using quicker those tools. And I think banking is one of them where they are really going fast because they need to assess risk. And AI is a fantastic tool to help assessing risk. So that's one of the start of an answer. Anyone wants to build on that?
You know, I'm interested on how entertainment is getting shaped. I know that there is in Los Angeles like a writer's strike about the salaries and all these things, but we just see ChatGPT writing plays and writing entire ads. Like I was watching an ad, I think it was by Ryan Reynolds' company, and he literally filmed the ad that was purely generated by ChatGPT and ideated. And I am excited about this because it's kind of a new future, fresh, innovative ideas, but also I feel for the people that worked and have studied in all these industries. So, but yeah, entertainment for me is a huge one. Maybe new ways of entertainment as well. Number two, building experiences. So experiences themselves, we're going to be more immersed. We're going to have, new, different things that we've never experienced before. And number three, education that we already touched on.
I received some question about giving some practical examples. So coming back to assessing risk in banking, or maybe you are on an e-commerce website and you want to buy a sofa. The sofa is quite expensive, and suddenly you get a button which says you can pay in 3 installments without interest. Oh, fantastic. But why did they choose you? Why are they offering you this opportunity? Because actually, maybe someone else next to you, they are not offered that opportunity. That's because they've been assessing plenty of data points about you. They've seen how you are scrolling around the website. If you have been already a customer or if you are using this website, they have your past purchases. So they are able very quickly to draw the picture, and they have access also to what you paid before. So they are able to offer you a deal. And that's what AI is doing. They're detecting patterns to see which person is most likely to repay, and which person is actually not likely to pay. So it's a very practical example of AI impact helping retailers to sell more. Then if you want to sell more and keep on buying more, that's another topic, but that's an example. So I've got some other question. Oh, would you expect AI to change employment from local to more global? That's a very interesting one.
I don't think AI per se is going to do this. Indirectly, sure, more tools will be created where, we don't need to be there in person, but I feel that there are some things that AI cannot replace, which is kind of the personal connection and the intuition and, the feelings. So I'm surprised, but I will say that I do not believe it will fully replace this.
Yeah, I would agree with that. I think what we're seeing is that AI is being diffused out to the local level, essentially. So I think you'll see it in action really more locally than globally.
For me, it's an opportunity to create local jobs in places which are out of the center. Like in France now, average size cities are able to create more jobs, and people can also work from anywhere. But for me, it's an opportunity to regain power for deprived areas, actually.
Right.
I'm going through the question. What are the best strategies for startups to recruit AI experts? So the war for talent. Do you have any tips for those people? They might be in need of recruiting people.
Well, there are a couple of things. I think the right question is, why do you need to recruit AI people? Is it because you have a lot of data, you want to train them and see what happens? Is it because you want to explore whether AI is for you and your startup? So I would challenge you with the question, why? And then I want to say there are tools that let you train models or use pre-trained models on your own, no-code tools, like Google AutoML is an amazing one. So yeah, I push back with the question of why. And if you do know the answer, then you know the exact skill set you need. Maybe you need a machine learning engineer. Maybe you need an AI product manager. But yeah, I would add some strategy to that question.
Yeah, building on that, you're completely right. The why is super important, and we have more and more tools with, for instance, libraries of models. So you don't have to build it. You can find a model that people have tested and use that and input your data. So places like Hugging Face, for instance, DataIQ help you to also not recreate the wheel. And that's an interesting question, which, I mean, data scientists need to be was the hot job for the past years, but now it's a bit of a less hot job. So there are a lot of, there is fashion also in tech.
Yes. I would also add for any startup to be extremely conscientious and thoughtful and strategic about your org chart. Connecting to what Marilee said, because that is the advantage that you have against legacy companies, is the ability to potentially do things much more efficiently, leveraging AI tools. So think about employing consultants strategically, employing tools, and really there will be incredibly productive teams of 5 to 10 people that will wow people at how large they can get companies now. So being strategic, I think, is really critical.
Oh, absolutely. So to conclude on our panel, do you have 3 tips to share with people who are watching us about actually how AI is changing what skill matters and tomorrow's jobs? 3 keywords, 3 things you want them to keep for themselves and as a takeaway, a little gift for the participant. 3 keywords they can think about later on.
Number 1, I know it may be overwhelming and scary, but we have to embrace it. So embrace is the word, number 1. Number 2, once you embrace it and understand it, advocate for it to everyone else. So we embrace, we advocate. Number 3, stay ahead of the curve, because it moves so fast that if you're the type of person that wants to really dive in, you are going to stay behind. So figure out your own ways of staying ahead of your curve. You know, like newsletters is one, like reading and studying. So embrace, advocate, and keep learning, because this moves fast. And thank you so much for having me.
Right.
I really appreciate it.
Love it. Who wants to be next on the 3 keywords?
Well, I think I would add to what Marley said. I think one of the key things we're going to have to do is think, not only embrace it, but also think about how AI can enhance what we're currently doing. That is, improve what we're currently doing, go beyond. And I think for education, we are on the cusp of really having to rethink an awful lot of what we do in education. I think it's going to be pervasive. It's not going to be just in the engineering school. It's going to be across the university. Just because AI is going to affect so many careers out there, education is going to have to really anticipate that, and across the university, things are going to have to change. So it's I think another word I would leave is pervasive. Is that this is going to be a pervasive change. So
great.
And thank you for having me. I really appreciate it.
Pleasure, Bill. Who wants to be next? Indy?
Happy to go next. So I would say my 3 things would be: 1, don't look at the derivative effects of AI. Look at the radical other shadow of it. That's where value is going to be discovered. The value of AI is largely going to be driven by very large data manufacturers. I think the nature of organization is going to change fundamentally. If you want to compete with the Googles and the Facebooks, you're not going to compete on recruiting data engineers by paying them 700,000. You're going to recruit by fundamentally reimagining the nature of the organization and how value is constructed in embodied senses. To flip the model, be more radical, because Google and Facebook are 19th century institutions guised as tech companies. Build a 21st century organization. That is going to be the real imagination, step one. Step two, I think, recognize what it means to be, I'm pretty convinced, I would say, being human and unlocking the full capacity of being human will be your fundamental asset in the 21st century. Remember, we're living through the second Engels pause period, where return on capital has gone like this and return on labor has stagnated. Whoever unlocks the return on labor to unlock the new capacity will actually leverage the key moment. Forget the technologists, reimagine the organization, reimagine human capabilities. And number three, I would say, is I think it's going to become, look at a whole new class. If the press release is basically irrelevant because it's only going to be read by machines, reimagine the interfaces with being human. And what does that look like? I think we've got a revolution on our hands, much deeper than what looks like a surface technology game. It's a revolution of how we exist and relate in the world. And it's much, much bigger. If whales can talk and we can talk back, what the fuck does that mean in the future?
Jacob, do you want to add one word?
Yeah, I want to talk to whales so badly. That's really exciting. And dogs as well. I would say, as I said earlier, concision is going to be increasingly important because we've conflated the volume of text with deep thinking, and there's a bifurcation now, which is extremely upsetting to our notions of what it means to be a good writer. I would encourage people to explore. There's the barrier to entry in so many different fields now. It's going to be much easier to get to that first bit of knowledge production or creative production. And lastly, just to iterate, because often friends of mine have had bad first experiences trying things in ChatGPT or other tools. It takes work. That's where a lot of the human value will come in, is smartly thinking how to iterate and interweave these tools.
So my keywords to conclude, it would be rethink. So rethink what is value for you. Rethink the traditional criteria of success of working. And decentralized learning. Accept learning will be decentralized and make the most of it.
We cannot hear anymore. Can anyone else hear, or is it just...
Oh, are we being cut?
I can hear you.
Okay.
I can hear you. But...
It was about rethinking.
Yeah, same.
Yeah.
Okay, so rethink value. Rethink problem you want to solve. Rethink education, accept it will be decentralized.
As soon as they mute it.
And rethink education, accept it will be decentralized. There is an echo. Maybe my twin arrived. I don't know. I want to say a big thank you because it was a fantastic panel. I was a bit scared because it was 1 hour. I was scared it was 1 hour and I thought, oh, that's long. But actually, I enjoyed it fully. It was fantastic. Thank you, and hopefully we'll be more human and meet face-to-face soon. Thanks, Bill. Thanks, Marily. Thanks, Jacob. Thanks, Indy.
TUMO is a free-of-charge educational program that puts teens in charge of their own learning. Over 25,000 teens between the ages of 12 and 18 attend TUMO centers each week after school. TUMO offers 14 learning targets at the intersection of technology and design. TUMO's educational software, the TUMO Path, creates customized learning plans for each student that dynamically adapts to their pace and interests over time. TUMO makes learning exciting using 3 formats: self-learning, hands-on workshops, and project labs. Self-learning with help from coaches. Hands-on workshops led by TUMO's workshop leaders. Project labs with international professionals. At TUMO, there are no admission requirements, fees, tests, diplomas, teachers, or semesters. Beyond hard skills, students develop soft skills such as an entrepreneurial mindset, the ability to self-motivate, time management, collaboration, problem solving, and a sense of community. There are several TUMO centers in Armenia, with more on the way. With international centers in Paris, Lyon, Beirut, Berlin, Zurich, Moscow, Tirana, Kiev, with more to come. As teens progress completing activities and workshops, their best results are uploaded to a digital portfolio, which acts as their living diploma. For more information, visit tumo.org.
There's a bunch of background noise. I don't know what that.
Hmm.
Maybe you're in an exciting place. I don't know.
Is it better now?
Well, a bit. Yeah. Whatever.
Okay. Apologies. Great. Okay, let's kick things off. Hello, everyone, and I'd like to thank you for joining me for this special fireside chat. My name is Heige Storian. I'm TUMO's head of engineering, and today we'll be exploring through conversation the interplay of AI and education, a topic that's, I think, of significance for maybe all of humankind even. And I'm honored to be joined by Stephen Wolfram. Stephen, thank you so much for joining us today. We're really, really happy to have you with us.
Pleased to be here.
And I kind of want to start things off with a question about the past. And actually, before I dive in, I want to share a bit about your background, Stephen. I think you're so well known that I skipped the introduction, but I want to say that, you know, as the creator of Wolfram Alpha and the Wolfram language, the founder and CEO of Wolfram Research, and the author of a new kind of science, that your work is all about computation and knowledge. And so we're very happy to have this opportunity to chat with you about AI and education.
two things that I know are top of mind for you as well. So let me start things off with a dilemma that many of us are facing at the intersection of AI and education. AI is quite good at coding, and it's only improving at that. And those of us involved in education around programming and computer science and machine learning are asking ourselves whether we need to change the way we teach. And for a long time, you've been advocating teaching computational thinking, kind of operating more at the conceptual level rather than at the level of what computers can do today. And I think of it as just a more imaginative approach that emphasizes the abstractions that we should be thinking about rather than the means that we have at our disposal today. What do you think computational thinking can give us to guide us in thinking about teaching computer science and machine learning in particular?
Well, gosh, let's see. I mean, I think the first thing to understand is you want your computer to do something. First of all, you have to have an idea of what you want to do. And the job of people like me is to make it as automatic as possible to get the computer to actually do what you want. But you have to first sort of formulate in some clear way what it is you want the computer to do. And people, I think, get a bit confused because the effort of programming languages has been to kind of pander to what computers naturally do. The thing I've been doing for the last 40 years or so is trying to build up this idea of computational language, the idea of a language to describe the world computationally in a form where it's kind of a good fit for humans and it's something that can be implemented on a computer. And kind of the story of that ends up being, have your computer be able to talk about chemicals and cities and movies and images and sounds and so on. Have that be something that the computer is intrinsically able to do, not something where you're learning coding at a low level where you're asking, set this variable to this value, step through an array and so on. That, to me, that's kind of the old world. When I started using computers now in the 1970s, kind of anybody serious learned assembly language. That was the thing to learn. It was, you couldn't really use a computer. You couldn't really understand computers unless you were using assembly language. Nowadays, essentially nobody learns assembly language. And that's because, there's at least one layer of sort of programming language effort that is very widely used in the world. Kind of our effort to build computational language, that is the future. And, millions of people use what we built and have used what we built to do sort of lots of things that kind of at the leading edges of R&D and education and so on. But in a sense, it's kind of the inexorable future that we are trying to build something where we're taking the way humans think about things and kind of making it as automatic as possible the part the computers are supposed to do. Now, in terms of how do you learn to think about things computationally? Kind of, I think it's a very interesting kind of arc of intellectual history. I mean, before, the big discovery of our species, in a sense, was language, the ability to describe the world in terms of words and not just, pointing at things and so on. And then we had various kinds of formalizations above language, so to speak. Logic was one of the early ones, kind of taking, there are sentences that are constructed like this. They can all be abstracted into this thing we call logic. And then there was mathematics, where we kind of have another way to formalize talking about the world. And mathematics has been powerful enough that it's driven a large fraction of kind of engineering that has built the modern world, so to speak. But now we have another kind of form of abstraction and formalization, which is computation. And the question is, can we learn to think computationally about things? Can we learn to kind of do the things that, we kind of recognize that something like logic is a useful way to kind of organize one's thoughts, mathematics. Likewise, computation is a way to organize our thoughts. It's not just a question of feeding the computer, it's what variable you should set in this part of your program. It's a question of, can you represent the things you're thinking about in computational terms? Can you crispen up the way you're thinking about things? And I think the thing that I kind of like to it's kind of like, how can you take, sort of all the topics that we think about in the world and kind of sort of formalize them so that they can be computational, and maybe we can pick some actual areas and talk about sort of what's involved in doing that. I think the thing, if you look at education at all levels, there's, if we want to prepare kind of the students of today for what will exist in the world in the future, we kind of need to prepare them for computational X for all X, so to speak. And what does that look like? What is, computational literature? What is computational sport? What is computational chemistry? Well, that we understand a little bit more about. But all of these things can be thought about in computational terms, and that's kind of that's the way that we kind of take them forward, because it's kind of like the one, human nature doesn't change much over the course of history, but the one thing that changes is technology and the progress that's driven by technology. And technology is really about taking things that we used to have to do ourselves and automate them in some way. And we now have this sort of huge source of automation that that it's a question of how we teach people how to kind of make use of sort of the superpowers that now exist with computation and with computational language, and use those to kind of do computational X for whatever X they want to do.
I see so much emphasis on the power of this way of thinking, and it's almost like the software that our brains are running can make such a difference in our capabilities. And I kind of want to talk a bit about the software running in your brain. You've had a remarkable life with exceptional academic excellence, incredible accomplishments, with the products you've created, the technologies you and your company have created. How much of that do you believe relates to your own educational experiences? That's what I'd like to learn more about.
Sure. Yeah, I mean, I've been lucky enough to kind of have been able to alternate in my life between doing kind of technology and doing basic science. I've done about five cycles, so to speak. And, in a sense, the things I've built are a result of having kind of understood sort of a bunch of kind of frameworks for thinking about things, and then building tools based on those frameworks, using those tools to understand more frameworks and so on. My own education, I grew up in England. I went to very good schools, top schools, and so on. I realize in retrospect that I was the top student. I didn't really internalize that particularly at the time. I objected violently to learning Latin and Greek and things like that, only to find that in today's life, I have a Latin and Greek dictionary within reach, because I end up having to.
I wonder if that would help you with prompt engineering.
Well, I don't know. I think I wrote a book. It's kind of elementary introduction to Wolfram language, and kind of Latin is a nice, structured, simple language in a sense. And to me, as I wrote that book, I was kind of thinking about the books that one learnt Latin from, because that was kind of another example of a structured language. But I think the thing that my own sort of educational trajectory, I started out sort of doing projects about things very early in my life, and I started off doing research and things like that. I didn't really realize that questions that didn't show up as exercises in a book would be any more difficult than questions that did, and it wasn't always true that they were. And so by the time I was kind of actually early teenager, I was, doing research and so on. And although I wouldn't have probably called it that, I'm trying to solve problems. I was writing things, eventually academic papers and things like that. I think one of the things that I was probably lucky in was that in my education, there was kind of an idea that people should actually think about things. It was not so much, there was a certain amount of learn these facts. I have a decent memory, so it was pretty easy for me to learn facts. Turns out learning facts is useful. People, sometimes in modern education think, oh, no, learning facts is old, last century. Nobody needs to learn facts anymore. You can just look them up on the web. Use Wolfram Alpha, whatever. I don't think that's correct. And I think that the thing that we are increasingly going to see, and a thing that has been great for me, is the more you know, the easier it is to figure out new interesting things. And I've been lucky that I learned some fields like physics and so on when I was pretty young, but I've gone on learning things throughout my life. It's been pretty helpful that I've had sort of the driver of building tools that try to cover lots of different fields. So that's kind of been a reason to learn those fields, as well as kinds of things that I've been led to from basic research. But I think a key thing for me personally is, I've gone on learning many different fields over the course of time. And I think for people sort of trying to give the best education today, learn a broad range of things, learn facts, learn how to think about things. I think it's people say, well, education is about learning methods for solving problems and so on. But actually, the most important thing is to figure out what problems are worth solving, so to speak. To answer the question, what questions should you ask, which is something that tends to kind of get left out of education. And I think I was kind of lucky that partly because I was doing my own kind of projects and so on, I spent a lot of my younger years doing exactly that, figuring out what questions I was interested in asking, rather than kind of learning the procedure by which one would answer particular kinds of questions. I mean, I myself, for example, I got interested in doing physics pretty early in my life, and in doing physics, one of the drags is you have to do lots of mathematical calculations and so on. And I rather quickly sort of objected to that and said, this is all very mechanical. And then I realized, gosh, one should be able to get a computer to do this. And so that my early lack of interest in sort of doing the algebra by hand, so to speak, is kind of what led eventually to things like Wolfram Alpha and Mathematica and so on, which have, I hope, been useful to lots of people other than me, although I've used them a lot myself. That was kind of the reason.
I think I can speak for many calculus students that we're all very happy that you got tired of doing those calculations yourself and you built a tool that can do them for you and also help everyone else, because I personally use Wolfram Alpha quite a bit, especially with integrals in calculus. They were extremely helpful for understanding the kind of broader toolbox ways of solving those problems. So I'm very grateful. And this brings me to my next question. To what extent do you think that those experiences that you credit with both your education, but also kind of the time you spent seeking problems and tackling the problems that you selected based on your own intellectual curiosity, to what extent do you think that could be replicated and scaled by modern tools, of course, including generative AI?
Yeah, well, look, I think that people following the things that they're interested in and exploring them, that's a great thing. We do these summer schools and summer camps and so on, where, we get students, high school students, grown-up students, so to speak, to do projects. It's really kind of, it's great to see how one can go from kind of an idea about what to do to the actuality of doing something that has never been done before by using, computational language as a tool, so to speak. That's a spectacular thing. And it's a thing where it really feels like people are getting a superpower, so to speak. Once they understand kind of computational language, they take the things they're thinking about, they can, if we did our job properly, it's easy for them to take those ideas and sort of turn them into reality. Now, in terms of how to scale this kind of thing, I think, for example, in the summer schools, summer camps we do, I personally been much involved in like picking projects for lots and lots of students and so on. That's not so scalable. The thing that we are experimenting with right now is using LLMs to do kind of personalized tutoring. And it's hard. I mean, this is not one of these, oh, you just plug it in and it works kinds of things. I've done plenty of, quotes, impossible projects in my life. This one is, if you look at the history of kind of computerized education, so to speak, not with people out of the loop, so to speak, there's 70 years of failures. And the question is, do we finally have a technology stack where we can actually succeed? And you connect ChatGPT to Wolfram Alpha and Wolfram language, and it You can do lots of things. You can ask lots of questions. Sometimes it'll even give you the right answer if it knows to we have these things now called chat notebooks that are pretty nice as a way to interact with kind of the mixture of the LLM, which is really doing kind of providing a linguistic interface to essentially common sense and a certain amount of knowledge, but that is not its specialty. I mean, its specialty is figuring out what the best next word is, so to speak. And it's absolutely spectacular and scientifically very interesting that it's possible to get a neural net to write a fluent essay, so to speak. But that the thing that it's doing is, in a sense, the kinds of things that humans do fairly easily. That humans can spin words out fairly easily. Humans can use common sense fairly easily. The thing that we have learned over the last, 300 years with mathematics, maybe 50 years with computation, is that there is something different and more formal that is possible for us to do that really allows us to go much further than the unaided human can go. And that's where, that's the superpower that leads to computational X. And that's the thing that we are trying to teach people to interface with, or we should be trying to teach people to interface with. I mean, people can go back to sort of the way they were before kind of modern formalization and just say, we'll just figure everything out by pure thinking. But the fact is we have this kind of sort of extremely powerful piece of automation effectively, which is formalization. And the question is, how do we best connect to that, so to speak? And how do we teach people to formulate their thinking so that they can connect to that? I mean, in a sense, when you do mathematics, a key part of that is kind of the notation for mathematics, which got invented maybe 500 years ago now. Before that, you did math by talking about it with words. It was pretty difficult to explain yourself. What we've been trying to do with computational language is to provide essentially a notation for thinking about things computationally. That is both something that humans can think in terms of and that you can get your computer to help with. But I think the thing that I'm sort of hoping to see is can we kind of connect both, I mean, in building kind of a LLM-based tutoring system, we have to be realistic about what's out there in the world of education. And 99-point-something% of what's out there is not teaching kind of computational thinking and computational X. It's mostly teaching things that people sort of already know fit into things in the world, like traditional math teaching and so on. And and so one of the big targets for LLM tutoring effort is being able to teach those traditional kinds of things in a personalized way. The kind of stretch goal that I think is really interesting is being able to teach the things that one isn't teaching right now in a more streamlined way. But in terms of the things that one is teaching right now, I think the thing that is pretty interesting is the ability for an LLM to several things. First, to frame whatever one's talking about in the terms that are interesting to some particular kid. You're doing word problems in math, the kid is interested in baseball, you can phrase every problem in terms of baseball. That helps to provide kind of encouragement, engagement, etc. First kind of thing. Second kind of thing, the kid tries to explain back to the LLM what they're thinking. We've never been able to take, in an automated way, the kind of the thinking and working that kids do and do anything with it. With an LLM, we potentially can. I think the way we see it in the end is that the LLM develops a model for the kid and knows this is what the kid understands, this is what the kid doesn't understand. This is, at this moment, the kid is confused in this way. If I just say this one thing, that's going to unlock that particular confusion, the kind of thing that a good teacher would be able to do. I mean, and the thing that's kind of interesting about it, in typical teaching situations, it's not, one-on-one teacher and child. It's more, teacher and 20 kids, 30 kids, whatever it is, which makes it impossible to do the kind of personalized reaction to what the kid has understood or not understood that we get the potential to do with LLMs. So I think that's the kind of direction we're going in. I can't yet say how long it's going to take, how well it's going to work. I think we have kind of the the 70-year opportunity right now to actually make this work in a way that's never worked before. You know, exactly how that will play out, I don't know. We can talk about lots more details of it, but that's kind of the broad outline.
That's extremely exciting that you feel that, you know, we might be on the cusp of this, and just this idea of having quality attention scaled out to every learner, paying attention to what they're thinking, finding those spots where they get stuck and helping them. That's just thrilling. That can be so impactful, I think. Unfortunately, we are low on time. I'm going to ask perhaps our last question. So this isn't quite a fireside. Maybe it's a candle side chat in this case because of our time. But something that really interests me, and I hope this interests other people as well, Stephen, is, you know, I'm always interested in what someone like you, what does your mind go back to, the questions that are on your mind. In particular, I'd like to know, what's the question that you spend the most time thinking about with respect to AI in education? Kind of the thing that you're kind of coming back to, making bits of progress, but is top of mind for you?
Well, I mean, you know, the big picture has been, how do we describe the world computationally? The sub-case part of that is, how do we get people to understand? Once we have understood, and we have understood by now a lot about sort of how to understand the world computationally, the next question is, how do we get people to really embrace that, understand it, take advantage of it? That's something that is less my kind of expertise in a sense. In a sense, I think we've, you know, I'm completely confident that the things we've defined are what a century from now people will say, that was the obvious thing. You know, everybody knew it was going to go that way. The question is, can you accelerate that to the point where we can deliver those things to people today? Can we have people really understand the value of these things? Can we have people not say, we're teaching coding, we're teaching programming, we're going to teach them how to set variables? That's like the assembly language of when I was a kid. That's not what people should be doing. What people should be doing is saying, what's the thing you're interested in about the world? And then thinking, how can we take that and kind of think about that computationally, crispen up your thinking about it, so you're not just kind of saying the words, but you're able to kind of formalize the way you're thinking about it and have your computer help you, so to speak. That's you know, if for me, that's a thing where, I mean, I've kind of understood, you know, a recent thing I understood is, how come, you know, the high end of the R&D world has used our technology for a long time. Lots of CEOs of lots of well-known tech companies use our technology. It's the only thing they actually use in terms of programming with their own fingers, so to speak. Yet the typical kind of rank and file programmer is not using it. And the question is, why not? And I think the answer is because it actually requires thinking. You know, we've provided a tool where every time you use it, it's taking what you think and kind of amplifying it. And it needs you to think. You can't just be kind of turning the crank for a month, sort of saying, I'm going to write another piece of code. I'm going to write another piece of code. I'm going to have done something today because I wrote a piece of code. It requires that you're actually formulating your thoughts in a computational way. And then it's letting you that hour, that day, so to speak, achieve a bunch of things. And that's what's valuable to kind of the CEOs of companies, the high end of the R&D world, but it requires kind of concentrated thinking. And the thing that I think is a great and very, very important challenge is, how do we provide the capabilities for that kind of concentrated thinking to everybody? Because everybody's going to be able to do it. This is not one of these things that is, oh yes, you know, you have to have this incredibly special sort of spark of something to be able to do it. Not the case. I mean, if people like me have done our jobs correctly, we built something which is kind of ergonomic for all human minds, so to speak. And I think so for me, that's an interesting challenge. And so, for example, right at this moment, I'm working on some basic science stuff, but one of my next big projects is to try and create sort of book, course, etc., about computational thinking, and to kind of one version of that would be just take all the stuff I've learned in my life and write it down so other people can learn from it. but that's kind of so that's an upcoming project that I'm hoping to embark on fairly soon, and probably I'll do it like I've done many of my recent projects in a very open way. So there'll be sort of pieces of it that show up and live streams about it and so on. So that's something I'm planning on and hoping for fairly soon.
I'll be keeping an eye out for it. That sounds really exciting, and I'm really excited to read more about this from you. So thanks so much for your time, Stephen. It was a real pleasure, and I hope you have a wonderful rest of your day.
Thank you.
Thank you.
Bye-bye.
Bye.
So we're now about to embark on a very interesting panel, a meta panel in a sense, because until now we've been talking about the way machine learning, advances in machine learning are going to change the way we do education. In this case, we're asking, how will these advances change the way we teach machine learning itself and even computer science? So to this panel, I want to welcome a very appropriate group of panelists. We have Sanja Fiedler, who's VP of AI Research at NVIDIA and Associate Professor at University of Toronto. Pat Yogpradit, who is the Chief Education Officer, I think it is, at Code.org, and has recently co-founded an initiative called Teach AI, which I hope we'll talk about more. Ali Al-Islami is with Google DeepMind. He's a principal researcher, and Eddie Aftandilian is with GitHub, where he has worked on the original team working on the Copilot, GitHub Copilot. And so, again, a very appropriate group. And I want to jump right in with the top level question of, given that it seems like machine learning has become more high level, at least accessible at a high level to many people like me, who previously would have needed a lot more kind of fundamental expertise to even delve into it. It seems sometimes that the way we're teaching machine learning today, in computer science, is maybe too low level. Maybe it's 2-3 months ago. Things are moving so quickly. What are your thoughts on the spectrum of just stick with the fundamentals to it's all about prompt engineering? And maybe we start with Sanja.
Yeah, thank you. Thank you for inviting me. Can you hear me?
Yes, perfectly.
Okay, fantastic. Yeah, I think there's a couple of questions here, right? What we should be teaching, fundamentals or what level, and then more about keeping up with the fast pace of AI. So I think the intent of education is to give students fundamental knowledge about different fields, right? To prepare them for future jobs, right? And at the same time, to get them interested and maybe even enthusiastic about different fields. And it's very clear now that AI will be a very important skill for the future, right? So it's very clear now that we need to think about how to introduce that and maybe more levels of education. So why I think fundamentals are important, right? So we have calculators, but we still teach students addition and multiplication, and we have tools like Mathematica. We just saw Steven. I love Steven. But we still teach students calculus and algebra. So I think the more you understand the core fundamentals or like the core principles behind the technology, the better you can both use, interact with it, understand its limitation, adapt to the fact that this is a changing technology, build creatively on top, and innovate new technology. And there's still a lot of innovation needed in this domain, right? But I do think that we can teach fundamentals at different levels of mathematical and programming competency. So right now, and please correct me if I'm wrong, it feels like we're mostly teaching AI through its mathematical foundations and mostly as courses in higher education, so fields like CS and engineering science. So we kind of expect the students to be equipped with mathematical and programming foundations in order to really understand the core technical aspects of machine learning. And I do believe that this needs to continue to exist. I think we need to be training people that acquire a very deep level of expertise so they can keep pushing this field. However, like undoubtedly, the barrier to entry has significantly reduced in the past 2 years, like you're saying, right? So there's many tools available, from machine learning frameworks to open source projects, SDKs, train models, AI services, right? And with services like ChatGPT, Midjourney, a much wider population is now interested in interacting with AI. And they come with different levels of mathematical interest. My nephew, who is 11 now, asks me about AI, and whenever I visit and I have a meeting, he kind of sneaks into the room and tries to see the latest, greatest results, and then asks me about it. So I think it's very sensible to go maybe one crack higher, one level higher to what we're teaching, and introduce AI courses earlier in education to a much wider subset of population, kind of teaching them different levels of skills, right? So for example, just kind of speaking from experience of how I teach my nephew, just maybe at a more intuitive level, what AI is, evolution or history, what fields is it being used currently, examples of how, have them think creatively, what other use cases they could imagine, maybe get some interaction with the useful tools that already exist, like PyTorch, maybe at some point Scratch incorporates like some simple AI blocks, so we can go even like earlier in education, and then maybe have students kind of think how to formulate different problems in terms of AI. It's very clear, right, that AI is now outputting very complex outputs, and we should be maybe teaching students very critical thinking about judging its output. Yeah. In terms of the hype or the latest, greatest, right? School seems like the curriculum is meant to stand the test of time. So I do think that some core principles are much more valuable. We should not be teaching or chasing hype, rather than kind of preparing the students for the fact that this is a very evolving, rapidly evolving technology, and they shouldn't be overfitting to just, this one particular technology available now, right? I just can't imagine a class being devoted to prompt engineering for GPT-4. So maybe that kind of knowledge is available outside of the main curriculum, right? Like online specialized schools or programs like Tumo, Coursera, they could be, kind of keeping up with the pace. But I think that in school, we should be thinking about, fundamentals, and maybe like go one level higher and kind of put it earlier in education. Yeah.
Yeah. So it's interesting, if I could extrapolate a little bit. So you're saying widen the spectrum, fundamentals have to stay, but also you now have an opportunity to also work at a higher level for some audiences. Just to plant the seed for maybe a follow-up question, at Tumo, for example, we do teach machine learning and we do teach fundamentals, but within a limited time frame. And so we can't just also do other things. So we kind of have to pick our battles. And I bet a lot of schools are in the same situation where they would love to do the whole spectrum, but have to make some choices. And we're currently going through a lot of stress thinking about that. But I think that's a good segue to Pat, who has been working in computer science, kind of promoting computer science education, also at the high school level. What are your thoughts, Pat?
So the question, Pegor, was how should we be revising the way AI education is done? Right. Is it too low level? How do we focus on the fundamentals? And I can speak about the US. I can speak about the world, but I can speak primarily about the US because I have data on the percent of high schools, public high schools in the US that actually teach any computer science. And it's actually about 57%. Okay. A very, very, very far from, 80, 90, or obviously 100%. That means that there are schools right now in the US, it might have 500 students, a high school. This is primarily high school data. It might have 500 students, it might have 1,000 students, it might have 2,000 students where they can't even take computer science even if they wanted to. And so if they can't take computer science, obviously they're not having the opportunity to learn anything about AI as well, because at least in the US, most AI education is taught through a computer science class. I mean, we all know that AI goes beyond computer science and engages concepts from, engineering or psychology or whatever. But when it comes to the technical computing aspects, that's going to find a home in computer science. So if you don't have a home, and if computer science is not even being taught, AI education is not being taught. So to revise something, it first needs to be taught. And that's the issue in the US right now. Now, that's not the issue in Korea, or that might not be the issue in other countries. But in the US, it's quite a problem just to have a home for AI education. Second, in terms of what Sonia was saying about the fundamentals, I totally agree. I have nothing to add about that. I think the most important thing is just we need to define the fundamentals that that have longevity over time. And Sonia said that again, like that we shouldn't just be chasing what's hot right now. We should be focusing on things that matter for a long time, like prompt engineering. I agree with Sonia as well. There shouldn't be a class on prompt engineering. There should be a class on problem formulation and just understanding how do we design problems in the first place. And if you know how to design a problem, you know how to create a prompt to answer that problem. And then lastly, this is where I spend most of my time, and this is why Code.org, the International Society for Technology and Education, Khan Academy, ETS, and the World Economic Forum created Teach AI. It was to figure out how to actually make this all happen, how to actually get into schools, how to provide the policies, how to provide the guidance, the curriculum and assessment exemplars, the AI literacy frameworks, so that we can guide education leaders into this new AI-driven world. And so that's where I spend most of my time, focusing on the how, not just the what.
Just taking advantage of that, tell us more about Teach AI in terms of what is it a consortium? Is it what kind of entity is it? How does it work?
Yeah, so Teach AI is an initiative. It's not an organization in itself, and it's dedicated to 4 main areas: policy work, awareness including things like just dispelling misconceptions around AI, things like that. But then community building, and then lastly, capacity building, mainly among policymakers, administrators, and teachers. And so there are a variety of projects in each of those 4 buckets. We will actually be releasing a guidance toolkit in the next month to help any education system provide guidance to their schools or their districts or what have you. But that's one of the biggest problems right now in schools. As we know, a lot of schools, a lot of countries banned generative AI or ChatGPT last year. And those bans actually still exist because they don't know what to do. So the easiest thing to do is just to ban it. And so what we're trying to do is provide that guidance to them so that they can be educated and provide the guidance to their schools and feel like they don't have to just ban it.
Right. Thanks. And Ali, as I move to you, I want to add a little twist to the question, which is around the fact that ML research has spawned kind of an empirical side now, with people studying how, let's say, GPT-4 behaves rather than, let's say, designing how it should behave. Is this new, this empirical approach to machine learning, and does it add anything to this question of the fact that it now exists, if it is indeed is new? Does that change anything about how we should be doing AI research at an academic level at universities?
Yeah, first of all, very happy to be here. Thank you for the invitation. Yeah, it's an interesting question, and I think my personal answer is that I don't think it's new. Even when I started in this field about like 10, 15 years ago, machine learning as a whole had an aura of kind of empiricity to it. And I remember even back then, so many people in other fields were skeptical of machine learning precisely for that reason. Now AI, what we call AI now, so these big language models or diffusion models and so on, definitely feels like it's even more empirical than it was 10 years ago. We used to have structured models. We could kind of prove theorems about them. We could write equations. Now, a lot of that seems to have gone. And it actually raises an interesting philosophical question for me, perhaps a little bit off topic, but maybe it's just the property of the universe that as we approach, general intelligence, that we may have to give up on understanding it using equations. It might just be an emergent system, and we study it like we study brains or we study biology. So that's an interesting question to think about. Now going to the question of like, how does that affect how we think about it and how we teach it, and connecting to the previous conversation, is that I actually think we sometimes scare ourselves into thinking that the technologies we're dealing with are mystical or mysterious or really difficult to work with. And we do this by the way we name things. So I remember back in 2011-12, when deep learning was starting to take off, many people were genuinely scared or confused by the words deep in deep learning. And it took a couple of years of people giving talks and writing papers and educating for people to realize that deep just means a bunch of layers. There's nothing magical happening there. It's a bunch of neural network layers working in tandem with each other. And the size of those models also rapidly became manageable, so much so that everyone has a deep learning model in their pockets now, and you can train it very easily in a day. And I think the same will happen with large language models. I think, for instance, the word large has the same effect for us now, and foundational has the same effect for us. But I think in 10, 15 years, we'll just see these as not scary technologies that we'll be building on top of. So if I were to suggest anything about the way we educate ourselves about these things, is to try to not make them feel unapproachable. I think they're very, if not approachable now, they will be very, very soon. And so kind of going in with a sense of, I can do this, makes a big difference in my view.
Well, one reason it seems less approachable is not just because of the naming and the mystique, but it's because it's becoming kind of the purview of kind of an inner circle of commercial companies, yours included, that have a lot of the knowledge. Plus, it's so compute intensive and data intensive and just plain expensive that in itself makes it seem inaccessible. And maybe, hopefully, that's also a misconception. But what's your reaction to that?
No, I totally get that. And it is true that at the moment, if you're training these large models, there's only really, if you're training them from scratch, there's only really a few places where you can do that, where you have the right hardware and data. But again, like drawing the same analogy, I remember very clearly when people were training ImageNet classifier networks. I remember when there were only 5 labs in the world that could do that. And I remember the names of the people who had the hardware to run it. It was that small. And that's really changed now. And I think the same thing will happen. The flip side of this is that I think some of the most interesting research actually happening right now isn't in just training the models, but it's in understanding the models, in benchmarking them, in figuring out how we're going to use them. So figuring out like what kinds of interfaces we build to them. Mm-hmm. And that stuff is actually, I don't think, limited to the big companies at all. And we've seen the open source community do like really amazing things. Just as an example, literally yesterday on Twitter, there was a paper doing the rounds where folks had identified what they were calling the, what was it, the curse of reversal, I think something like this, where they were showing that, models, even though they might know who Tom Cruise's father is, won't know if you mention Tom Cruise's father's name that Tom Cruise is his son. So very simple facts about, A equals B implying B equals A 2 days ago, we didn't know that language models are really bad at that. Today, we know that they're really bad at that. And this is someone just very carefully probing the models to build that understanding. And now that we have that, we can go back and hopefully kind of fix this problem. And it's going to be absolutely crucial, this kind of insights to making progress.
Wow, that's interesting. Okay, well, Eddie, going to you, and I'm sure you have a lot to say about ML as well, but since you're the co-pilot person, what about whether computer science should change in that? Because a lot of computer science is about learning to code, at some level. And even at the level of algorithms and data structures, AI can go a long way. I know it's an assistant, but still, it somehow feels that if the way we teach CS doesn't change at all, that would be a surprise to me. What do you think about that?
I definitely agree. I think computer science education is already changing. I think you're already seeing this with how, introductory college courses are taught. Let's sort of go through your comment. You mentioned sort of grammar and syntax. I agree. Those are going to be, they're already less important. Models already generally do a pretty good job of generating syntactically correct code. Another thing that, current models are very good at is knowing the ins and outs of specific APIs. So like learning the common libraries for a language, whether they're, part of the language or, very popular open source libraries and so on. But I think from a computer science education perspective, those are not really very interesting anyway. And the interesting parts are things like teaching algorithms, being able to analyze algorithms and data structures and understand, the computational complexity and the memory complexity of these algorithms. From an industrial perspective, the interesting problems are really about like large-scale design. How do I design a system to accomplish a task with, the latency requirements I have or the reliability requirements? How do I break up a large project into smaller pieces? What are the right abstractions for those pieces? And I think it's actually very important to understand the subtleties of the algorithms you're using, because they can have a large impact on the performance of your system. And these are all things that at least the current generation of models are not yet good at, and I expect they won't be good at for a little while. And so I think this gives educators an opportunity to focus on these more interesting topics and spend less time on syntax. One other topic that I wanted to bring up that Sonia mentioned in her first comments was about reading code, right? So in a world where AI coding assistants are ubiquitous, I think reading code is going to become more important than actually writing the code, because programmers are going to be asked to quickly evaluate just an endless stream of AI-generated completions. And this is also applicable even in the non-AI world. Like, I spend a substantial fraction of my time reviewing other people's code rather than writing my own code. And this was actually a big shock to me when I came out of school and went into industry, and half of my job is reviewing other people's code. And so I think it's actually very important, especially in this AI world, to teach students how to read code that they didn't write, understand what it does, and find any bugs in it, or also to be able to modify it to do what they want. This is another thing you have to do with AI-generated completions. A lot of the time, they're in the right direction, but they're not quite what you want, and you need to tweak them so that you get the behavior that you want out of them. And these are skills that I think will be very important in a world where AI coding assistance is ubiquitous.
But do you think we'll be able to keep up? Is there a kind of a speculative world in 10 years from now, maybe 5, where there's so much code being generated by AI that we can't review all of it, and we'll be reduced to just functionally testing it, and then it will end up being a black box of code? That's a concern I some people have, including for text, because it's being generated at such large amounts that no one can actually read and edit it, and code must be the same thing.
I don't know. I mean, it's hard to speculate 10 years in the future, especially given how things are moving right now. I can tell you that on our team, we do conduct studies with professional developers to ask, where would you like to see AI assistance and where do you not want AI assistance? And one of the things that we consistently hear is that developers want to understand the code that they're committing to their code bases. It's very important to them. They're going to have to own this code long term. They're going to have to be able to edit it, and they don't want sort of unvetted AI generated code added to their projects. They want to be in the loop, and I don't know if that's going to change.
Well, they use APIs as black boxes, right? They don't open them up and see how they work. They trust them.
Other people are using those same APIs, right? Like there's some amount of sort of trust in that if this API is popular and it's widely used, it's probably, pretty close to correct. Whereas, code generations happen, they're very specialized. They take your context and they may or may not be correct.
Right. Okay, that's very interesting, especially coming from you. I'm gonna kind of rewind and go back to Ali and ask you about a question that I shared with you online, which is more about kind of trying to think about changes in kind of the flavor of how foundation models are built. And in particular, Google DeepMind has talked recently about memory and planning as important kind of fundamental ingredients in the mix, which are not now present in things like Bard and GPT-4, et cetera. Do you think, first of all, tell us more about that if you have any thoughts, but in linking it back to education, whether there's a research and academic kind of push that you foresee along those lines, and whether, because that would be very interesting and maybe less empirical at some point.
Yeah, so I can only really speak for myself, and there's dozens of teams working on lots of different topics, from as you said, planning and memory and language models and all sorts of different areas. From where I stand, again, I think what I'm really seeing is the minification of language models. So instead of thinking or treating them as these massive behemoths that we can't really control, we're beginning to realize that they're actually much more manageable than we previously thought. And then when you see them as small objects, you start building systems around them. So you start thinking about, what if I had multiple language models? How would they interact with each other? What if I had a language model sitting within a larger environment? How would the model interact with this environment and learn from those interactions? How would I put things inside it? How would I give it tools to use? How could I augment it with a memory bank? All of a sudden, many classical computer science and classical AI concepts you find coming back. As you said, concepts like planning and reinforcement learning and memory and robotics and so much else. So I think there's that happening for sure. But then not just to kind of sweep all the innovations on the language models themselves under the rug, there's a ton of stuff going on in training better models that isn't just about making them bigger or giving them more data. So, I mean, one thing that isn't really talked about so much is that even in the past year or two, the efficiency with which we train these models has really increased, like orders of magnitude. Not just like in efficiency in terms of compute, but also efficiency in terms of the number of data points they require and the time it takes. And then people have been working a lot on multimodality, as I'm sure you know, not just text, but other modalities like vision and audio and so on. And even questions like which parts of the training set actually matter. Like, do we need more data or do we need better data? Do we need more data from the internet or do we need more interactions with humans and so on? And then like the final piece I wanted to mention is just like evaluation, you know, even in the past year, there's been so many advances in figuring out how good the models are. And this is by no means a solved problem. You know, as I said, just in the past couple of days, we've learned, you know, massive holes in their performance that we didn't know about. And evaluating them themselves then leads to lots of advances. And, you know, again, to close it back, you know, once you know, for instance, that they have poor short-term memory, you go in and try and build systems that address that. So there's definitely a loop going on here.
Anyone want to jump in? Lots of interesting threads there. And Sanya, I'm thinking of you around multimodality and video, computer vision.
Yeah, I mean, Ali really summarized it really well. I think we are really just starting on this, right? There's so many amazing results, and you know, obviously the open source community is pushing for reducing the amount of data to train, right? Humans can learn from much less than reading the entire internet and do really well, right? So I think that should be possible. Reducing the size of the models, increasing speed, both training, testing, increasing diversity of the samples, making the models safe. I think there's still a lot of really interesting work to be done there. On the multimodal aspect specifically, I think if you look at GPT-4, it's still image, so image text. So we're not seeing as many video models. Maybe in the past 6 months, we've seen some foundation video models. I think Runway has a really nice model. NVIDIA also has some research models. So I think in the next few months, we're definitely going to see a lot more of that. Clearly, we live in a world that is moving. It's 3D, and you know, there's video coming. It's not just static images. And I think there's a lot more to learn there and capture behavior events, you know, have built this kind of inherent knowledge into the AI to really maybe enable applications more on, you know, embodied AI and you know, understanding videos.
Yeah, if I may just jump in there, speaking specifically about video, this is like a pet passion of mine, which is, you know, when we think of the stream of text on the internet and how much we've been able to learn from that, I think there's a similar amount of information to be learned from just watching the world pass you by, even without text or language. And I don't think anyone's cracked that problem yet, you know. Just put a camera or put thousands of cameras, just look at the world and you'll learn so much about physics, about behavior, about shape and geometry. And we don't really have models that kind of take advantage of that yet. And I think it's going to be the next thing.
All right. So I'm going to bring it back a little bit to policy and Pat, looking at you. If you're in a position where you're advising on policy and you're in a very fast-moving situation like the rest of us, it seems like a daunting task. How are you approaching that? And what are some of the things you're recommending to policymakers?
So I'd like to define two terms because it answers your question, Pegor. Guidance versus policy. Okay. So policy is, you know, they're both technically like recommendations, or actually no, not even recommendations. They're both like generally guidance, but policy is like formally approved. It's less flexible. It goes through a much more rigorous process. Oftentimes it's mandatory, while obviously guidance is more flexible, easily updatable, often more practical, and especially at the education level, more focused on instructional guidance versus like regulatory or systems guidance. And what I spend most of my time doing is convincing people that at the minimum they should be providing guidance to schools, teachers, and students. Mm-hmm. And they shouldn't be, they shouldn't feel pressure to develop policies right now unless those policies are very straightforward policies that already reflect existing policies that they have right now around obviously privacy, safety, security, things like that. But in terms of developing policy around things, even like, like I guess plagiarism, like what actually counts as plagiarism these days, right? Codifying that as a regulation is very scary right now because we really don't know how AI will play out in schools. And so at the minimum, yeah, I mean, we have a guess, and sure, you could guess and encode that in policy, but really at minimum, let's just drive some guidance right now and issue guidance statements. And so even over the last, like the beginning of the school year, unfortunately in the US over the summer, not enough school systems got on board and delivered guidance before the school year. But now that the second wave of like, oh my goodness, what are we doing around AI has hit schools, a lot more education systems, both districts and states in the US have gotten on board. At the federal level, internationally, it's still quite slow because those systems are just slow anyway. And oftentimes what is, if there is guidance at like a Ministry of Education level, it's often so vague that it's not very practical at the school level anyway. It's just high level principles, and the people who have to actually implement these policies don't even know what to do with it anyway. They don't have the capacity, they don't have the bandwidth, they don't have the expertise. So again, that's why groups like Teach AI are creating like the policy or guidance toolkits to actually bridge the gap between these high level ideas that are coming out of groups like UNESCO as an example, and bridging the gap between those ideas and what actually needs to happen on the ground to guide classroom practice.
So I live in Armenia. I'm connecting from Armenia right now. And a couple of years ago, they introduced chess into the official public school curriculum. I thought that was cute / funny. Now they're introducing AI. So they have a pilot program to introduce AI in teaching to high schools, not just CS. And you guys seem to be nodding. Does that make sense? What does that mean? Does that mean we're teaching AI adjacent math? Would you do that in your countries? What are some?
Pegor, something like that, it might have like some policymaker behind it who's like, oh, AI, it's a new thing. We need all our kids to learn AI.
Yeah.
And then what really matters is like what happens after that, right? And like, so is everyone just learning the latest machine learning algorithms, and how useful is that? Or are they learning, more of the fundamentals? Are they learning it in a culturally relevant way, in a fun way? Or are they just learning like the boring math behind it and then actually being turned off from it later on? It all depends on like how it's implemented.
Yeah, and I don't have the details. I do know that they're trying to figure out where to get the teachers, but.
Oh yeah, that's a problem too. Again, this is our world, right? Pegor, trying to figure out how to actually make these things happen.
Right.
If I may, I'd just like to jump in very briefly with just the observation that I think it's not just about how we make AI and how we use AI, but also educating people about the downstream effects of it. So, thinking about what does AI mean for the arts? What does it mean for literature? What does it mean for law? Even the philosophy of AI. I think one of the important things that's happening right now is that we're realizing we're perhaps less special than we thought in terms of being the smartest beings around. And I think, in terms of, where that places us in the universe, that itself is a really interesting thing to study. Even questions around what is the theory of mind, what's the difference between a mind and a brain? These things aren't about language models, but the fact that we have language models make them so much more fun to study now. And I think these would be really wonderful to teach even to high school students.
Right, right. And also, I guess, some of the literacy aspects around ethics and safety and all of that. Eddie, do you want to come in?
Yeah, I was just thinking that, you know, from the perspective of teaching, say, high school students, I think like a course focused on applications and things like the ethical considerations and so on, you know, could be a gateway to get more people interested in computer science, right? Most of the people, you know, I think growing up now are going to have AI as part of their lives going forward, but, you know, almost none of them are going to be the ones developing the models that power this stuff. More likely, they're going to be applying the models to, you know, their daily work or their daily lives and so on. And, you know, part of the reason that these models are so exciting is that they've made things that were previously impossible, like very accessible, right? Like, if I want to build a system that can, I don't know, classify natural language, you know, 5 years ago, I would have to collect a data set and learn how to train a model. Now I can just hit an API, give a few shot examples, and I've got a classifier. And I can classify, you know, arbitrary natural language. I think like these types of sort of like simple exercises to give students a flavor of what, you know, even today's models are capable of are very within the reach of, high schools, and might serve as sort of a gateway into, for some students to get, you know, more deep into this field.
I wanted to repeat something that Eddie said before about, or actually, Sonia started it about talking about syntax and, you know, programming language, languages and variables and such. I'm excited that generative AI can create code for students. Very, very excited, because it's just the next evolution in the abstraction and accessibility of programming, period. Right now in schools all over the world, a lot of students are learning programming first through a block programming language, where if you're not familiar, audience, basically you can type code with words and letters, or you can actually snap blocks together like building blocks and create a program that way. And that's just easier because you don't have to worry about spelling something correctly. And you still get the same types of output, and definitely the same type of, you go through the same type of thought processes. And generative AI just explodes that and makes it even easier. And what that does is it allows the social studies teacher or the social studies student or the language student or the mathematics or chemistry student to suddenly incorporate creation with computing ideas at any point very easily. And so finally, we will have what we all look for, like true integration of these kinds of ideas and these artifacts across the curriculum. I think that's very exciting. It's gonna, you know, basically language becomes the new programming language, which is great.
I would guess that we lose a lot of students because of syntax, right? Like, if you can remember back to when you learned to program, you would end up with these frustrating like compiler errors that were irrelevant to the actual concepts you were trying to learn. And there was very little way to get help with them. And now you can feed those error messages into, you know, ChatGPT, and it'll just tell you, oh, you forgot a semicolon here. And I have to think that this is going to be good for the accessibility and growth of computer science in the future.
I do have to say there's one major concern. This whole panel has mostly been about like positive about AI in education, right? There's huge concern I have about the loss or the underemphasis of critical thinking, because if kids have something that can do an easy thing for them, they will use it all the time. And for us as adults, that's actually okay. It augments our abilities, and then we get to focus on the higher order thinking and the design level, big level perspective. But kids never actually, they're learning these things for the first time. So they actually never get to learn the high levels. They never, their learning's almost flipped backwards. And I'm just curious what's going to happen when they get these super powerful tools. Do they just rely on them too much and they just never develop these muscles, and they actually become weak, very weak in some ways, and it actually doesn't support the long-term development we're looking for? That does concern me, and Teach AI is working on getting people together like you all to help us figure out how do we guide the future of CS education at the most introductory levels.
So Stephen Wolfram did a fireside chat just before this, and one of the things he was saying is that the Wolfram language, he says, is a very powerful abstraction to do translate computational thinking to actually getting results. And he says the reason programmers don't use it is because you have to think to use it. And it kind of resonates a little bit with what you were saying, Pat. His claim was it doesn't just do it for you. You do have to kind of know what you want in a very specific way, etc. On the other hand, programming with natural language, if it works, why would you need to kind of understand what's under the abstraction? We do a lot with natural language. We've done it historically. Tanya, do you have a reaction? Sanya, sorry.
Yeah, maybe just based on what Pat said about critical thinking, I just wanted to give an anecdotal example about my nephew. So he came to me and said, Sanya, can you help me log into ChatGPT? And I said, okay, let's do it. Why do you want to use ChatGPT? I said, oh, I have this homework and it takes me so much time to find stuff online. And I heard that ChatGPT can just help me. And then I said, okay, but do you know that AI right now is not necessarily always correct? So you would need to actually read it and make sure that the output is correct. And then he said, well, then I don't want to log into ChatGPT because I don't have the knowledge, right? I'm trying to learn and I want accuracy and I don't have the knowledge to judge the output. So I do think that it's critical thinking, and actually, students do need to have some level of knowledge to be able to use AI, at least as of today. And that's kind of where we need to focus on.
I can share another anecdote, a less hopeful one, which is that just literally yesterday, I was with a colleague of mine sitting side by side, and he had run a computer program that had generated a log of data, and I used ChatGPT to turn that log into a plot. So it provided a graph of, it was a loss of something, and it turned it into a graph, and we were like, oh, that's really cool. And then half an hour later, he wanted to do the same thing for a different log that he had. And what he asked for was the prompt I had given ChatGPT to create the figure. So he just copy pasted the prompt and then got the figure out. And this was for me the first time where instead of exchanging code to achieve a task, we were exchanging the prompt to achieve a task. And we're both engineers. I've been coding for like 20 whatever years, and him as well. But it was just like more convenient to just share the prompt. And I think that's already happening.
And you're saying this is less hopeful. Can you elaborate?
Actually, I want to be vulnerable with you all. Actually, that's me right now. So I'm looking at my side monitor. I have both Claude from Anthropic and ChatGPT 4.0, the subscription, open in different tabs, and I keep it open. I've had that set up. I've had this workflow for months now, and I cycle between both, and I have different chats, and it's heavily used. Now, one day, so this was before. This is actually why I got Claude as well. So ChatGPT, as you know, it goes down sometimes. It gets overwhelmed. And I had a request for it to do something, maybe like summarizing something, or I don't know, figuring out something that I could totally figure out myself. But it was down. So instead of figuring it out myself, I actually waited and kept on refreshing until it came back. And I refused to do the mental gymnastics myself because I knew that it could just do it for me, and I just waited. So if I'm getting that mentally lazy, so then I decided, oh, I can't rely on ChatGPT all the time. I need to get Claude as well. So I go to Claude for, So if I'm getting that mentally lazy, I guarantee you kids will not be developing the mental muscles that they need. And the thing is, I know that certain mental muscles won't be as important, but certain mental muscles will be even more important. And the question is the way we introduce AI use in schools to bolster other things, right, to get other benefits, what are the consequences that we have to deal with? And how do we know that, just how are we careful about this as we move forward? It's not just negative, it's not just positive. The negatives will come with the positives. So what are we losing here? What are we gaining, right?
Yeah, if I could jump in on that one. So at TUMO, we all the time we're trying to design learning activities that challenge the student in a certain way. So in this case, for example, the question would be for us, what kind of activity can you devise which can't be done through this lazy approach, which force kids to kind of deal with and one thing we were toying with is back when GPT 3.5 was not very competent, and especially in Armenian, it had a very bad Armenian kind of data set. It did things which were very revealing of how it works. For example, it would combine tokens into words that sound like an Armenian word, except they're not, right? And that was a very nice way to kind of have kids play with it and understand what a token is, for example, as opposed to a word, etc. And so maybe part of our task as educators is just to design these muscle building activities which take full advantage of the LLMs. So that's something we've been thinking about. Just want to throw that out there for comments.
Yeah, I mean, another interesting example that I've heard of, and maybe this is really basic for you who work in this field, is one of my friends is thinking about AI for University College London, one of the big universities here. And they were saying that they're switching from asking students to write essays, so because students can now just easily do that using language models, is the question starts off with a computer generated essay, and the student has to find the flaws in that essay. So it just assumes that they're going to be running the language model, but it kind of forces them to try and find the mistakes in it. And the lecturer can insert mistakes deliberately to know that there are mistakes and so on. So it's a completely different way of phrasing the problem that kind of flexes certain muscles. But it is true that at the end of the day, you're still not learning how to write from scratch. And maybe that's a useful skill. Maybe it will be less useful in the future. Not sure.
I always thought handwriting would die out. But what's crazy? I still, to this day, I'm 45 years old, and I still feel ashamed of my handwriting. And I remember the day in 4th grade when I decided I'm not going to work on my handwriting anymore. I actually refused. It was my first educational rebellion. And I just said, I don't care if I do well on this handwriting penmanship exam. I don't care, because we're just going to be typing anyway. And to this day, I regret that decision, because when I write a note to anyone, it looks like it's indecipherable and it looks like a kid wrote it. So, I wonder again what consequences we're going to pay later on for all these things that we're doing. And I just hope that I'm very pro, obviously, AI in education, but I just hope that we're not even necessarily just being cautious, but we're implementing the certain type of checks to allow us to know what's happening in a negative sense as well.
In another
that
panel,
reminds me a bit of
go ahead.
I remember when I was in high school and I was in a calculus course, like the graphing calculators, which I'm pretty sure are the exact ones that kids still use today, were kind of new. And I remember my calculus teacher was very dejected, and he's like, "Why am I even teaching you this? You could just do it on your calculator." but we learned it, and that mathematical foundation is important. If you want to go forward and do anything interesting in math, you need to understand how these things actually work under the covers. Maybe for most people it doesn't matter. Probably 99.9% of people aren't thinking about gradients and these kinds of things, but for some subset of people it is important. And it's interesting that we aren't all just learning how to use our TI-83s or Wolfram Alpha to answer these questions. We are still teaching students how to do it by hand and how it works.
So on another panel, they were worried about this writing question from the point of view of a lot of the people on the panel, academics and so on, are saying we actually think by writing, right? So to develop a thought, they have to kind of write text and edit, etc. And so it's not about the writing skill itself. Sure, that may not be needed, but they were wondering whether we lose a thinking tool and whether it will be replaced by another one, maybe. They weren't kind of coming down on one side or the other, but it seemed less trivial than just producing text, right? And for math, it may be the same thing. I mean, you use mathematical abstractions to portray problems as much as to solve, which is what you would do with Mathematica, right? What else? What else is on your mind?
Trust is on my mind, but not trust in the sense that technical trust or transparency or anything, but as we all know, AI can write email responses, and certainly can generate text that people cut and paste and pop into an email or a report or anything. And I find people, maybe because they know I use generative AI so much, but they're often asking me, when I ask for feedback about something, they're either half joking or not joking, and they say, "Hey Pat, was this written by generative AI?" And what they're trying to say is, this is not very good. Mm-hmm. And I find myself doing the same thing when I ask people to write things for me, or if I'm editing something, I'm thinking did they edit this? Did they even look at it? Because I know you're using these tools. At least edit, and maybe they did write it. But suddenly what happens is there's this constant questioning of the authenticity of things that you didn't question before. Even now, obviously we're looking at each other, everything's fine, but this could totally be deep faked. Mm-hmm. It's actually not that hard right now, but certainly in the future when we have consumer facing models where we can just, those already exist as well, but really good ones, right? So rather than my AI note taker that I can send to this meeting, I can send my AI image and just, it can respond to things, and if it's super sophisticated, it will be able to fool you for a little bit of time. There's no reason why I can't do that in this day and age when so many of our meetings are like this. So trust is something that's on my mind as something that we didn't have to deal with as much before, but now we do.
Yeah.
I do have one question. Someone, I forgot who, maybe it was you, Pat or Igor, said that we don't even have teachers to teach AI in high school. And that, it just dawned on me, that is an actual problem, how do we even teach AI to the educators? And that's probably something we should start on sooner. So I don't know what people here think.
Maybe AI should be doing the teaching? Is that purely science fiction?
It's not science fiction. Professional development for teachers is often not very good anyway, so it might as well just be taught by AI. AI can do it in a more just-in-time way, in a more personalized way, so why not? But yeah, Sonia, that's kind of where I spend most of my time, trying to figure out where do we get these teachers, and then when we have teachers who are open to teaching with AI or about AI, what do we give them that actually helps them in their practice? That is a big issue, and there aren't easy solutions for that. But that is one fundamental problem.
Yeah, and even standardizing curriculum across, entire North America or even the world, that, everyone is kind of have similar math or physics programs. It's not clear how that should evolve for AI.
Although a thought that jumps into my mind is that again, like if we distinguish between creating AI and using AI, it might be the case that the use of AI just happens naturally. So both the teachers and the students learn how to use it because it becomes pervasive in society. The same way that, with computer science, yes, certain teachers had to learn how to teach computer science. And as we heard earlier, there actually aren't that many of them. Say in the US, there's only like, say, 50% of schools. But the use of computers is, I imagine, everywhere in the curriculum. So both the teachers and the students use computers to write essays, to do experiments, to make videos, to search for things. Although now that I'm saying this, I'm also reminded that, many of the early pioneers in the computer industry, like Steve Jobs and Bill Gates and so on, they were actually really obsessed with education. Like they saw computers as primarily education devices, and they spent a lot of time thinking about how they educated people via schools to use the devices. And maybe similar thinking is necessary for AI as well.
So it looks like we're having too much fun. We're running out of time. Thanks everyone for a really high quality discussion. I hope we continue it in some other format, offline or another event. Again, thank you. And we're going to sign off. Bye now.
Thank you, Pegar.
Bye.
Thank you.
Thank you all.
Implications thereof could look like. I moved from there to running the organization that was in charge of self-driving cars at Uber. So I was recruited to help try to rethink effectively the Uber business model, that instead of relying on people in order to drive, in order to transport physical matter through the world, that we can instead have computers think about how do we get things to navigate the world, how do we understand how to build things that are safe, that are driving on four wheels in front of us. And of course, again, we sort of had this naivete going into it. This was maybe 7 years ago at this point. We had this naivete going into it. Like we literally trained these vehicles. This is an old story. We literally trained these vehicles in a place called Tempe, Arizona, in the United States. For all those of you who know the United States, Tempe, Arizona is a fairly white portion of the United States. And we brought these cars back to Pittsburgh, Pennsylvania, where we were based. And the cars literally wouldn't see people with dark skin. And so we had visceral experience of learning what these biases in these systems could look like. I went from there to run the technology team at the Democratic National Committee in the United States. Turns out the Democrats in the United States is the longest lived political party in the world currently. And so I spent a lot of time thinking about how do we use, again, technology to amplify the message of Democratic candidates who are running for office. How do we think about pushing policy messages? How do we get more people out to vote, and what those implications thereof could be? It's actually here that I felt the most visceral pain for all the work I had done so far, because I had to go and battle misinformation in the world. I had to figure out what would be the ways to actually actively combat and detect all the lies that were spreading throughout this information ecosystem that was being powered by these AI systems. But most recently, I've had the really good fortune of starting to create these set of stories. It's a podcast now, a set of stories around what AI optimism could look like, or more specifically, trying to fill the gap between AI optimism and AI doomerism. There are so many people, you can listen to podcasts today, there are so many people who will tell you all the crazy things that AI will be able for us to do in the future, whether it be changing the way we do education, medicine, healthcare, etc. And there are all these people who tell the story about the doom and gloom that could happen with these AI systems, whether it be the bias that I just mentioned in self-driving cars, or whether it be the disinformation that's really been spread. And what we've been really trying to do with these set of stories is try to figure out the optimistic lens, that you can both be an optimist, but be concerned at the same time. And in fact, that tension is what makes the world better. Like, we can think about all that tension simultaneously because we want the good, but we want to mitigate the bad, and therefore we can get to a world where we're really optimistic. And we've had some fairly amazing guests as part of this, and let me just do a quick run through of sort of a few of them and what they've talked to us about. So on the top left, we have Suresh Venkatesubramanian, who's a professor but worked at the White House to really think about what are frameworks for AI systems that could benefit society. Underneath him, maybe the counterbalance, you have Tristan Harris, who Tristan thinks a lot about what are the existential threats that AI can really bring, whether it be this concern that it could really end the world in some way, but maybe more nuanced, that this concern that could further exacerbate the differences in our society. We had a Senator Bennett, talking about the need for us to protect children, but if we're able to protect children, then our educational system could be amazing at the same time. Meredith Broussard, underneath Senator Bennett, talks about this great story of helping people understand what does it mean to build a fair system. She has this metaphor of sharing a cookie. Like, if you were a computer algorithm and you were told to split a cookie in half to share it amongst people, you would split it right down the middle, 50.0% to one person, 50.0% to the next person. But human systems don't work that way. Like, when I break a cookie, someone's going to get 51 and someone's going to get 49. If my kids break a cookie, a fight will erupt because it's unclear who gets the bigger piece. And so it's about answering those questions, is what she talks about, answering those questions which makes our society better. We need to confront the fact that these societal systems are not always going to be equal. Justine Bateman is an actress. A bunch of you who might be my age or older may have seen her in the 1980s. She was in a sitcom alongside Michael J. Fox. But these days, she's one of the biggest voices on top of the Hollywood writer strike, with an absolute concern that these AI systems can break the creativity of human beings. Because these AI systems are fundamentally looking backwards, she's concerned that no creation, no new ideas will show up if we rely on them. I don't know if I agree with her, but that's the position of the AI writers, the writers at least. But Sal Khan talks about how we can then take these engines and really educate children, give them personalized pieces of information so they can really make their world better. Eric Brynjolfsson talks a lot about this notion of automation versus augmentation, of like, how do we think about giving people tools to make them better at their jobs, as opposed to removing people from their jobs and replacing them with machines, and trying to find the right levers to pull there. And then finally, I talked with Maria Reza as part of this podcast. She's a Nobel Peace Laureate, Nobel Prize laureate, who thinks a lot about what happens to our societies as these AI systems come through. And the thing that I really learned from all of them is that in order for us to be optimistic, like, if you were to try to think about this really simplistically, how do we win as a society using AI? It's really complicated. There's no obvious answer, but there are a few truths that we can bring up from it. And one of the major truths that came through from all of them is bet on people. Don't bet on machines. And so the notion of like, I jokingly said at one point, I need to print t-shirts that said Team Human. It's not that we make machines irrelevant. It's not that we ignore machines. It's not that we think about machines as only in the corner. But we need to figure out ways to develop a techno-societal system which has us working with AI in order to make our society better. And there are three key truths that came from it. One is we need to build systems that are human first. A lot of people talk about these human-first AI systems or human-centric AI or human-forward AI systems, and that's exactly true, and that's the way that we all need to be thinking about these systems moving forward. It will all be under this notion of how do we give people the biggest amount of superpowers they possibly can so they can be at the most effective, they can do the things they want to do, and we can use humans to make the world better as opposed to relying on machines to do it for us. So in the case of automation versus augmentation, the real argument there is that it's really easy for businesses, for example, let's take a call center. It's really easy for businesses to eliminate all the people in the call center and just have a computer take those calls. Maybe that's the right thing to do. It's a very complicated question. But another way to look at it is what if we can give all those people in the call center superpowers? What if we can help them help other people faster, easier, better? What if we can build tools? I talked to professors at MIT. What if we can build tools that can help a call center person understand the emotional state of someone on the other side of the phone? Or think bigger. How do we make sure that call center operators don't get burned out because we're looking at the emotional state of everyone who's calling in, and we send some happy people to you and some sad people to you so we can make sure they have a real good balance? We can be building these systems in order to be aiding people to do their best work, and that's maybe one of the ways that we should look at. Another one of the key tenets that came out from talking to all these people is that we need to build systems that bring people together and not tear them apart. Left to their own devices, these AI systems have these tendencies to amplify the biases that already exist in our society. So for example, I took my self-driving car example. I brought cars to Tempe, Arizona, trained them on the people we saw there. They only saw white people. You bring them back into Pittsburgh, Pennsylvania. They didn't understand what to do with an African-American black person crossing a sidewalk. They literally would just get confused. These systems just exacerbate the biases. In Tempe, Arizona, a lot of white people choose to live there, so it exacerbates the bias that's there. In that 51 versus 49 example of the cookie, you could always be giving the bigger piece of the cookie to the oldest child, and without thinking about anything further. That's a particular bias that could just be amplified by these systems. We, as the creators of these AI systems, need to fight against that. We need to really be thinking about how do we bring people together. So in building a social media network, instead of sending people to all these different AI-based silos of information, what if we thought about it as an information diet, that you should see some of the stuff you like, but every once in a while you should see something you don't, as a way to broaden your view of the world or broaden your horizons of the world. Again, way more complicated than what I just